Good morning. Here I am again, Kai Aarne, the CEO of the MariaDB Foundation, and I'm welcoming you to the third and last day of the Paris MariaDB Server Fest. So today we start with Daniel Black, who recently joined the MariaDB Foundation in charge of innovation. So his presentation is about it's called It's All About You, Innovation That Matters. Innovation here refers to simple things like bug reports, but also a bit more complicated things like feature requests and especially continuous integration, where Daniel sees the foundation as a diplomatic service that fosters innovation in the MariaDB server ecosystem. After Daniel, we have the following MariaDB Foundation presentation. It's by our board member, Sergey Golubchik. Sergey will take a look at 10.5 and beyond. So it's a bit of a roadmap discussion and about the recent innovations in the server codebase. After that, we'll have Krunal Bauskar, a red presentation. It's about MariaDB on ARM, where there have been news recently about the ownership of ARM. But this is technically about how to integrate MariaDB on ARM and what hardware integration can mean for MariaDB running on a specific platform. After that, we have Federico Razzoli, Temporal tables. So temporal tables is a new feature. It's divided between what happened in 10.3 and what happened in 10.4, and Federico will do the differences between those two and what it means to have timestamps for rows and how that is being handled by MariaDB Server. And he's very much into best practices, not just what the syntax is, but how it can be used and how he suggests it should be used. After that, we will have a look at containers. So MariaDB database clusters on Kubernetes by Pengfei Ma, which is followed by one of the highlights of any meeting on conference on MariaDB. So Mark Mäkelä on InnoDB. His presentation on InnoDB is called Scalability Improvements in MariaDB's InnoDB Storage Engine, and it's going to be an overview of the things that have happened in the area of InnoDB in the MariaDB codebase. Then we have Peter Zaitsev. I listened to his presentation at FOSDEM earlier this year, and it was a comparison of MySQL 8 with MariaDB 10.5. And I think that comparison is valuable. It is an interesting look at what the differences are, the merits of each of the two products. Then another highlight of this conference, an Ask Me Anything with Monty. And if you know Mikael Rydenius, you know anything means anything. So that's a Zoom chat where I will be conveying your questions and some questions I've got earlier on to Monty, and let's see what he answers. And today and the last day will be concluded by one of the key features of 10.5, meaning MariaDB column store, so the storage engine for analytics that is now fully integrated into a normal storage engine position in MariaDB 10.5. And Sasha Vanyachin will be talking about building a relational data lake with MariaDB column store. So let's get the third and last day of the Paris MariaDB Server Fest 2020 started. And now for Daniel Black of the MariaDB Foundation. It's all about you, innovation that matters.
Hi, I'm Daniel Black. I'm the Chief Innovation Officer at MariaDB Foundation. I'm presenting to you from Canberra, Australia. It's spring here, and like spring, a fertile, mature codebase with a vibrant ecosystem and a foundation keen on nurturing your ideas will help, and its own, will help deliver MariaDB Server innovation to you. But who are you? Who are the people to which MariaDB matters? And we start by answering this question by looking at the download statistics off our downloads page, on our new downloads page, and we see that most packages are actually Windows that downloads. And while it's certainly acknowledged as a big proportion, we know it's more than just that. So if we take a look at the source code where it starts and look at how it's distributed out, we know that a limited number of people actually use the source code directly. So how is it distributed and consumed? So the MariaDB Corporation and the MariaDB Foundation together produce a number of Linux and Windows distributions. The Linux distributions include CentOS, Fedora, Debian, Mint, which is basically Ubuntu, OpenSUSE, RHEL, SLES, and Ubuntu. And we've given instructions for some other distros as well. So on non-Linux distros, there's AIX actually produce MariaDB via Bull Freeware and AIX Toolkit. Homebrew produce packages for MariaDB for Mac OS, which also work on Linux, apparently. I haven't tested. There's FreeBSD, and there's Open Indiana as an Open Solaris-based distribution, which are all maintained with many thanks to the distribution maintainers there and looking after their community. Linux distros, in addition, produce their own packages, and Windows is listed here because it's got a subsystem based on Ubuntu, and all the distro maintainers there do an excellent job sort of packaging it up as well. The Ubuntu packages produced by MariaDB are distributed further and packaged up into the Docker library containers of MariaDB based on the 2004 packages. And these are pushed to Docker Hub and as a container images for all the architectures that we actually distribute MariaDB for. If we look at how the Docker library image is consumed, it's pretty much any time you use MariaDB in a Docker Compose file, that will be using the Docker library file, most likely, without any setting changes. However, there's other uses such as MailCow of Liston and Ibis as projects that just use the container directly in their projects, and you might be using it the same in yours. The Docker library can also be used on Travis CI to test a number of open source and proprietary projects against the Docker container of MariaDB packaged up by the Docker library. The Docker library package of MariaDB is also consumed by OpenStack in their Trove product, which is their database as a service, which along with 11 other databases provides an integrated part of the OpenStack infrastructure as a service platform. MariaDB is also used within other projects in OpenStack, like Keystone, their identity service. If we look back at the Windows packaging, it gets packaged up by Apache Friends to XAMPP, which is a bundling of Apache, MariaDB, PHP, and Perl. And this is available for Windows, but also OS X and Linux. So XAMPP is currently maintained by Bitnami employees as a community contribution. However, Bitnami actually, as a VMware company, have a main product against MariaDB containers, and they produce a Debian rootless form of a container, which provides added security in the way it's packaged up. Bitnami also produce a virtual machine for download, and obviously that runs on VMware, but it's also available VirtualBox as well. Bitnami also provides some Helm charts for Kubernetes deployment of MariaDB, and that's used in a number of situations, namely Nextcloud, which runs their own Office environment, and this is one of the uses of the Helm charts. OwnCloud sort of forked off Nextcloud considerable number of years ago, and they actually use a MariaDB image based on Alpine, and they use that as a common storage platform for all their backend services. So Bitnami and Docker Library aren't the only ones actually producing container libraries. Red Hat have got like their own container platform, which is freely available as well. Bitnami, through the cloud marketplaces, allow you to deploy MariaDB directly onto Google Cloud Platform, AWS on Amazon, and Azure. But these aren't the only providers. There are a significant number of other providers that provide deployment to any of the hyperscale data centers of Google Cloud, Azure, Amazon, Alibaba Cloud, Tencent Cloud, IBM Cloud, or into service provider like ServiceNow. Bitnami's, I forgot to mention, was also produce either a single instance service, or you can deploy a multi-instance replication topology with minimal effort. And so this shows, that even down these stacks, they're adding value and making it easier for users. There are a number of database as a service platforms that strongly integrate the infrastructure tooling into a really self-contained product. And these include like SkySQL, which is a MariaDB Corporation product, Amazon RDS, AsperaDB relational database service for MariaDB TX, and that's from Alibaba Cloud. And these are just some of the beginnings of a large competitive market producing MariaDB as a service offering. So as we sort of zoom out and we look from like the beginning of the source to the packaging, to the repackaging, up to the hyperscale data centers, we see the vibrancy of the ecosystem, MariaDB source code, to drive so much diversity in the ecosystem. This certainly isn't a complete picture. Even just scratching this itch on, the finding the source to large scale instances doesn't explore all the paths, and there's certainly a number of significant paths that most developers, users, and me don't even know about. But this is actually more than just a distribution chain. What it shows here is the degree of innovation already in the ecosystem. Each of these elements has taken MariaDB of a form, added value to it, and allowed you as a user to consume it at free or minimal cost. But what we see in the consumption of MariaDB is beyond just what it got delivered to you, it's how you use it. And we can start by saying that SQL is not like the terminal interface where you manually type SQL like Raymond Boyce and Donald Chayman and kind of envisaged 50 years ago. The SQL terminal approach contributed to the large portability of the language and its growth in adoption, and it still serves a purpose in like testing queries and scientific learning and one-off business analytics. Robert's kernel Juniper kernel talk later talks about this interface and how it's been kind of reinvented as a Juniper notebook. However, for the most part, your applications actually consume MariaDB via connectors. These are language-specific constructs like connector C, connector J, Node.js, PyMySQL, ODBC, JDBC, PHP in a number of forms from MySQL to PDO, transform how a database is consumed by an application. And these provide a network layer and the marshalling required to talk to the database. And as an application interface, it's pretty much largely SQL at this layer. That may not be enough for you. There's other frameworks like Doctrine, Django, Drupal, Type ORM, Laravel, SQL Alchemy, but the list is really got too large, and these provide a number of ways to make SQL look more like code or objects, as the case may be, or just as a database abstraction layer if you're targeting more than databases. And this layering sort of builds on the connectors underneath and provides an added value into the way you write your code. At the end of the day, some of you may be even using a higher level framework than that. Things like WordPress, Wikimedia, Joomla, OpenCart, or hundreds of other applications provide an extensible framework to their domain, such that you can extend this and write your own application, even if it's largely a set of configurations of plugins and extensions. And these will just use MariaDB at the back end, but abstracted away. In addition to the application stack, there's a bit of infrastructure that's also needed around MariaDB. And the first set of this is around orchestration. In a sense, the distribution of packages is a kind of orchestration that allow you to reproducibly install the same product, but it also extends more to things like Puppet and Chef, more recently Ansible, Docker Swarm, OpenStack and Kubernetes, to name a few that provide a reliable, repeatable way of delivering actually the same MariaDB service into production. On the infrastructure side, to monitor databases, you need different tools like Prometheus, like Percona management and monitoring, PMM, like cluster control, like Monuing, to name a few that integrate with the server and provide meaningful statistics on what it's actually doing. To have high availability and horizontal scaling, there's additional products like MaxScale, HAProxy, Orchestra, and Galera, to name a few that enhance the ability to move across multiple environments, be redundant against failure, and just to deliver more throughput for the same server. Backup tools from like MyDumper to MariaDB Backup are part of the infrastructure, and their compatibility needs to occur. In the tooling realm, there's GUIs like PHP MyAdmin, query analyzers, Juniper notebooks to MyCLI, MySQL Tuner, and all these provide advantages to make the most out of MariaDB and make it easy. And lastly, I want to actually cover like multi-user services. So things like Plesk and WebMin and VirtualMin provide like a management interface to MariaDB used by service providers that give multiple users a specific view of the database. Things like OpenStack and Kubernetes and OpenShift also actually provide a similar kind of granularity in giving users a large control of the infrastructure, and in theory in a way that sort of can limit the impacts on everyone else. And so by looking at like the distribution ecosystem, the application layers, and the infrastructure tools, each of these independent providers actually work hard to deliver added value to you that you can deliver on to someone else, i.e. your customers and users, who at the end of the day should be oblivious to the fact that they've got a transparently infrastructure stack that's powered by MariaDB underneath. Okay, so now that we've sort of covered, how it kind of expands as far as distribution and use, I want to actually take a little bit of time to focus on how does it start? So the server development of MariaDB occurs in development and test iterations, and every now and then out of these pops a release. And the process repeats. So for connectors that aren't strongly tied to the development of server, at some point in time after the release of the server, those connectors actually pick up new features of the server, integrate them into their connectors, and they push out a release sometime later. If we continue further down the application stack, we see that frameworks, in a similar way to connectors, will wait on a release of a connector, see what features it exposes, and then try to actually incorporate that into their product. And as we can see, even though that this is really transparent, it happens all the time. The APIs are backwards compatibility. So the development of the framework and the connector layers largely occurs asynchronously. How if we look at, new features, it takes some time to actually propagate through the development communities to get to you. And so what I'd like to, every now and then, bugs happen and they need to go back to the layer that introduced the bugs, and, it's software, it's not infallible. Bugs will get fixed, and that delays the delivery of new features down to you. What I'd like you to imagine for a moment is if the development process looked like this, that the server development occurs the same time as the connectors development, occurs at the same time as the framework development. However, because a lot of the connectors and the frameworks are open source, they've got a rather minimal environment to get them going, and they've got their own test suite. So why not bring those aspects of the test suite, clone them down in a continuous integration and testing, so that the development of new features can start to be tested against the framework at the same time as the connectors are being developed and the server is being developed. And that way, when bugs are actually found, they're actually found before the release. And yeah, this is what I imagine it would look like. This is all really very new as far as a concept. Would have liked to actually show you more, but for instance, here's what we've got as a PHP build environment. It's not too hard, it's not too complicated. There's a few dependencies. A Docker file definition is all it takes to define what's needed to build, and along with some volumes and an entry point that starts the build process. Now, on that entry point, it's a combined build/test script. Don't worry about looking at this too closely, but this shows us cloning down a source code into repositories, doing a bit of caching to make sure we're not doing it every time, checking out the stable and development versions of PHP. And if we look at how PHP actually interacts with MariaDB. There's two main interfaces, the MySQL NG and there's the Connector C interface. And so both of these have to be sort of compiled and tested separately. And on top of these two mechanisms, there's a bunch of PDO connectors that presented in a different way, so we test those too. And this is the beginning. We've started to plan out on how to use this for other things and how to actually write a full stack of integration and testing. And we're not writing the test suites ourselves or the test cases, but we'll use what test suites are out and include those as part of our development process. This doesn't actually apply to the application stack. It can equally apply to the distribution stack, and examples such as DB deployer and Docker library are things that quickly sort of package up and use MariaDB as a package and also have their own test suites. So those are actually perfect to integrate in the same way. We're not going to achieve 100% coverage of these. However, with a careful selection of the communities that we want to test, we can pretty sure we've covered a significant portion of the server and of all the connectors in between. So it's likely that even though we're not covering 100%, that the things out there are using the same interfaces, so they're going to be bug-free by the time it's released. Well, that's the plan anyway. So all this building and testing infrastructure is off BuildBot. MariaDB Foundation has its own BuildBot, which has been running a significant number of architectures and compilers for quite a while, and operating systems to ensure that MariaDB Server is well tested when it gets to you. So we plan to continuously expand the range of testings to cover a sampling of the ecosystem of the application stack, of the infrastructure stack, and of the deployment stack. However, there's another direction I haven't actually mentioned. MariaDB depends on compilers and libraries to build itself, and these continue to evolve in ways that, compilers that change the way they transfer source code to object code. Libraries continue to add new interfaces and obsolete old interfaces. And without CI on these, it's hard to keep track of. We certainly don't want the case where a new compiler generates the wrong code and a user's stuck with a database corruption. So, let's try to find these faults early. Kernels from the Linux kernel, the Windows, BSD kernels to Illumos Open Solaris kernels provide new implementations and the compatibility needs to be tested. Multiple file systems are provided by Linux, and as database performance is heavily dependent on an efficient file system, this should be something we're actually testing frequently to ensure that the performance on MariaDB isn't getting degraded or regressed, potentially through code that isn't our own, i.e. kernel code. Also, kernels provide newer features like libio uring that provide ways of doing IO better than what was previously provided. And we should have a testing ground for those and making sure that they've got a path into MariaDB code base, and that we're actually sort of testing those not only from a functional perspective, but also from a design perspective. Are they actually going to be doing something that is useful for us, and perhaps offer suggestions on how to do things better? So how else is MariaDB Foundation serving you? I initially mentioned at the start that we've created a new downloads page. We've done this by cleaning up a lot of the user interfaces on these, auto-detecting the operating system and architecture that you're running on. And so what this will give you is actually a server product with less clicks and less confusion. We've also expanded the use of mirrors, particularly on the RPM-based distributions, so you should be able to get a faster download. Because we kind of acknowledge and see that the distribution stack is really extensive, innovation that was provided here was an API of versions and URLs and checksums on how to get at least like the first layers of distribution out. And so these can be used further down the track and to trigger the distribution in a more automated way. MariaDB also works on assisting contributors, whether it be a minor fix to get OpenBSD fully working on MariaDB, or whether it's helping some contributors actually provide like an alternate existing way of achieving their goals that they didn't realize was there. And sometimes we help contributors get past the trickier parts of serverless implementation, like this Unix time zone implementation. So it gave them tools to get past the task and allowed them to continue development and writing the tests because, hey, everyone likes finishing a project they started with, but not getting stuck down on the hard bits. MariaDB works by connecting communities when we kind of notice a bug report, well, something that looks like a bug in one forum that isn't reported into the bug tracking of the server. So in these cases, we noticed something was wrong. We alerted the people that had the knowledge and the skills to fix it, and they got fixed really quickly. However, breakdowns can actually happen. In this case, the Docker library, what happened was MariaDB fixed a time zone initialization for Galera, which really hurt other users on slow storage hardware that were using the Docker library. I guess developers actually test and run on fast hardware, so sometimes they actually don't notice these kind of effects. This fix for Galera was only meant to be for Galera, but due to its bug, it wasn't. So this was corrected in the next release. And it, from a MariaDB perspective, was like, okay, that's all fixed. That's solved all the problems. However, some of the people in the Docker library land knew it wasn't totally fixed, and they lacked a really clear communication to say what it wasn't fixed. There was communication in circles about which versions were fixed and which versions weren't. And so what we needed to do was, pick it up at a bug and do some more investigation. After spending a bit of time, we isolated the problem that there was a second transparent, well, non-obvious cause of like the same bug, which was in 10.3. The crash-safe ARIA engine started to become the default of the system tables, including those that store time zones. And it doesn't actually work so well on slow storage, especially with like 7,000 inserts of time zone transition, and each of these occur with an F-sync between them. And so what we saw is, large degraded performance on these. We were unable to get a fix or really write a fix for the next MariaDB release. So we pushed a workaround to the Docker library. And so before they pushed out their next MariaDB version release, they had a workaround to work with. In the process of actually looking through this bugs, we also improved the Galera InnoDB-based time initialization, and just looking at how Docker library uses MySQL install DB, we realized that it's a little bit dated and probably hasn't significantly changed since early MySQL 5.6 or 5.7. So it's in time for a revitalization. So were the Docker people, library people, happy with this? Their comment on the report that says 3 minutes down to 7 seconds was, pretty compelling. And so that was just a workaround, and work continues to improve this. And hopefully with the CI, we'll catch this sort of problem ahead of time. As I mentioned with MySQL install DB, it's used by a number of different communities, so I felt it was important to engage and write them up with a prototype and say, okay, this is how we're proposing to improve it. Does it cover all your use cases? And we've tried to actually make it fairly generic here, taking an extra file descriptor here so you can inject SQL into the bootstrap process, which is used certainly a lot with container-based instances, and certainly not the server installs where it was designed for. MariaDB helps out by helping users, whether that be on the MariaDB knowledge base, on Stack Overflow, on DBA Stack Exchange, on Reddit. Users come into problems, and yeah, they sort of need a bit of help and direction getting over things. So the MariaDB Foundation, people are looking at those forums to look for those kind of things. And occasionally on those things you'll see, bug reports and things that need to be fixed, or just ideas that need to be improved on the server to make it a better usable product. MariaDB also has its staff doing its own self-directed innovation, and Robert's Juniper Notebooks, I mentioned a couple of times, is a great example of this, and I strongly recommend you watch his talk. Another feature request I wrote, or feature improvement I wrote, was improving MySQL dumps. So instead of dumping out system tables, there's a bunch of create MySQL.user insert into MySQL user. We now put it as like portable SQL, like create user, and this applies to other things like roles on servers and a number of aspects that we see throughout the MySQL system tables, such that they can be imported in and a lot more portable between the versions. And so I plan on getting this into the next release. So the MariaDB Foundation also significantly works on the knowledge base documentation. As you can see, it's pretty much all done by Ian. So thank you, Ian. You're doing a great job in making sure all the MariaDB features are explained in a way that's actually usable. The MariaDB Foundation also creates podcasts on various topics to make it easier for the users. And sometimes we're just running or presenting at a MariaDB Server Fest. So another idea I've had on the back burner for a while, but I haven't had a chance to implement, but I thought I'd just share it with you as an idea. Load data actually works really great until there are errors, at which time the user is stuck and needs to resort to either splitting large text files or a complicated set of sed commands to clean up the data as it goes in, or write a looser table structure so it actually accepts the data, or writing your own import array. And all of these are really, really painful alternatives for what's something that's meant to be quick and fast and automated. So Oracle's database has an SQL loader that has a bad kind of data file where errors in the loader are actually pushed out to this file. But I think we can do better than that. So in this example, I've got a database of my pets, their year of birth and their weight. Nice simple table with a little bit of data on my dog. Sorry, a little bit of inconsistent formats on my dog's Jovi's weight, which is 30 kilos. So what we do is like the sequence storage engine, not to be confused with the sequences in general. The sequence storage engine uses the name of the sequence with an automated header, i.e. seq, to define the structure and the row elements in the sequence. So this was called like table discovery, and it was a large bit of innovation that was written by Sergey Golubchik in 2013, and it allows us to do a similar thing based on the name. So a structure that I'd like to see is, say, a load data errors table that is auto-created, and what this has is things like line numbers of the source code, of the data file that is read in, the full line of like that was read in that contained the errors, just in case you got a delimiter error. It's got a enum that describes which column had the error, and we've got like error codes and error text to make it all readable. And then what we do is we include each of the columns that were in the original table, and we make them nullable just in case it couldn't parse them. But beside those, we put out the parsed broken up text that was part of the original CSV file. So for my pet database that loaded, if we extend the load data syntax to refer to this load data errors table, what we get is a table here that has like one entry that contains that line number 2 has an error for in the weight column for Jovi. It couldn't really parse the weight, but it had its original text form as 30 kg. And so what this will make it useful for is with really large data imports or scripted imports, that you'll get tables with something you can actually do something with. And you can do something with it in SQL rather than writing a scripting or a language around importing CSV files. Because, hey, you used load data because you didn't want to do that. If you've got any further ideas on enhancement to this, please make a comment on MDev 13046. And yeah, I mean, there's a number of concepts that haven't been explored. For example, if do you want more than one error table per for target table? Do you want like the file name introduced as one of the columns and make that a joint primary key? So it's all possible, but yeah, tell us your ideas. Load data isn't the only thing that can actually generate a bunch of errors. Things like alter table can lead to lossing conversions, and maybe it's worthwhile to actually have some of those losses like captured, rather than, them A, being either silently ignored, or B, your alter table failing halfway through and needing to roll back on that. Another cases where the feature of SQL's strictness can come a little undone is, say, in replication. That data pushed through from the master side to the replica side isn't always the same or has the same effect. Table structures can be different, so maybe we want to capture those kind of errors in the same way. We also at MariaDB Foundation acknowledge there's a backlog of feature requests, and these we need to actually get through and deliver on the things that actually matter to you. We know by looking at the code base, there's other, fertile grounds for further development of the MariaDB server. The engine independent table statistics was written in version 10.0.1, and it provides the framework for choosing better optimal query plans on running servers, on running queries. The table discovery, like I mentioned with loaded data, has a number of different applications, and yeah, it's ready to use. Functions, as of, I forget which version, there's actually an aggregate features that is available. Additional authentication mechanisms are possible, especially since like 10.4 actually has the ability to do multiple authentication mechanisms that are actually possible for a single user. So there might be opportunities for enhancement or integration into other products and systems for that. Encryption plugins, which were written either 10.0 or 10.1, also are a rich avenue for providing ways to encrypt the storage of data. And there's standards like KMIP that might be something that's portable and ready to use in that respect. And these are just some of the ways that MariaDB delivers a better server for you. We want to ensure the ecosystem is compatible. We'd love to hear about your feature requests and bug fixes that you want fixed, so please vote on these. Please write up your ideas for new feature requests, or just talk to us about problems that you have with working with MariaDB and SQL in general. And we'll see what can be done to improve those. We're happy to help you develop your own features, particularly if you want to actually make them available for everyone else in the server code base. And we'll use our collective knowledge to continue to make MariaDB better, because it's all about you. Thank you, everybody. Bye. Any questions? See if my dinner arrives exactly as we start.
Thank you, Daniel Black, and welcome in Canberra, Australia. Hi there, Daniel.
Hi, welcome to be here. Pleasure to be here.
So what time do you have? It looks like a bit nightish kind of the time of day.
Yeah, it's just coming up like 10 to 8. My dinner is probably just about to arrive on the doorstep, but hey.
Okay.
My dogs, yeah, so it's all happening. Perfect way to finish the presentation.
Indeed. So innovation was the header, not just of your presentation, but it's also part of your title. And we've had a lot of discussions, you and me, about what innovation means. That it's sort of a big thing, but it's sort of a sum of many small things. So what is innovation in your mind in the case of specifically MariaDB?
Innovation is about capturing the really simple things that actually have a lot of benefit. I mean, you saw probably Eric getting really excited about, you know, me talking about the load data and how that we can make it so much better with by building on like the foundations, like what's Sergey has, you know, already written into table discovery. So we've got a mature foundation that we can actually grow on, yeah, to give a really good user experience.
So what the viewers probably don't know is that you, before joining the MariaDB Foundation, you were the most prolific contributor of code to MariaDB Server.
Yeah, true. And it was, yeah, just in a lot of small areas that I thought this needs fixing up. You know, whether it be a packaging bug in one area. You know, I think one of my early ones was like writing, say, system D and making, okay, what would MariaDB look like under system D? And now, you know, it's a fundamental nature of how it's packaged on, you know, so many distributions and distributions beyond that.
So compared to most developers of MariaDB Server, you have a what one could call external background. Many of the core developers who accept code, and accepting code is for the viewers one of the most difficult things to do. You have not been working inside the MariaDB corporation or the or MySQL AB. So how do you think that this different background of yours, what kind of effects does that have on your ability to help innovation?
Right. So I actually came into doing a DBA role a little bit accidentally. You know, a previous employment wasn't working out. Ian just sort of said, "Hey, you're a pretty smart guy. I have done a course on DBA with you, and you know, how would you like to go and do this for a while?" And I did, and I absolutely loved it. Just working with clients and making, you know, SQL work for them, and then, you know, started writing a little bit too much code and wondering how to bill it to a client, and they go, I kind of actually need to find a job that actually does, you know, development. So, and as you look through things, you go, well, okay, that needs something to monitor or explain it, or this thing just needs to be nicer. So yeah, that's sort of how I'm coming at it, and from, you know, a former user who is, you know, trying to do stuff and being thrown really curly questions from clients to say, I want to do this. It's like, let's try to work it out.
So what I think sets you apart is this view from the user's perspective, as opposed to looking inside the code. And I think continuous integration is one of your favorite topics because of that reason, that you realize how important it is for MariaDB Server to work within a larger context. So you mentioned both Travis and BuildBot. So what are the really basics about continuous integration that a DBA or a developer of applications with MariaDB Server would need to know?
So, I mean, CI, continuous integration. So, and more actually continuous testing. So it means that we're, you know, every stage we're actually building the server code base, we're running it, and we're running everything from like unit tests to little stress tests on the server itself before it even, you know, gets packaged up and consumed by you. So it's really important to, you know, find those bugs and errors, and you know, early on in the process, you know, while there's still an opportunity to fix it, and while you know, and certainly have happened, you know, a few times when I was doing DBA work years ago, that was like, right, deploy something and it breaks, and sure, it was in a test environment, but it certainly adds a delay to, you know, when you get a workable product or
Yeah.
a workable new feature that you want to use.
So innovation, the basic resources to innovate, how do we, in the MariaDB Foundation, we have a couple of these places. I'm thinking about the knowledge base, and I'm thinking about Jira, and I'm thinking about the backlog of pull requests. So how would you map out these things? Like, what should I know as a developer of application about for instance, Jira?
Right. So the thing I guess to know about like MariaDB and its community is that we are looking out for new ideas, that your experience as, a hands-on DBA or developer is actually really important. And if you sort of see something that needs improving, grab a Jira account, jira.mariadb.org, log in, do a quick search to see if someone else has written the same sort of thing. And even if they have, make sure you vote on it. Make sure that it's described really, really well as to why this is important, to get this change through. How much will you actually benefit from it?
I
Because
think that's
those
a
are the
point that
really
I need
good
to
stories.
underline or even interrupt you, because I think you're saying now for enhancement requests the same thing that Sanya Alexander Belkin was saying about bug reports, that it doesn't really matter to say that I think this is important or I think I have a bug. The bug needs to become reproducible, and when it comes to the enhancement request, the understanding of why this is important is good to document.
Yeah, and it's the why that sort of drives the motivation of developers and people that look at it to say, pick it up and go, yeah, that is a good idea, or I see that in your description here you have considered X, Y, and Z other alternatives, but they can't work because of some other reason. So show an explanation of the topic, show off your knowledge in the particular area, and yeah,
so
make it saleable.
You picked up in a discussion from yesterday's conference about YAML and JSON. So would you care to describe what the process looked like, what you thought about that, and how the process would work like with these low-hanging fruit kind of things?
Yeah, well, I saw that. Yeah, okay. So a user wants to see, YAML output instead of JSON, for whatever reason. And it's like, okay, and as Sergey Petunia actually described, it's a really simple transformation. It should be one for one. Okay, so your first step would log into Jira. It doesn't exist at the moment, so yeah. You're welcome to write that now. As I want to convert JSON to YAML in the output. I like this because YAML looks really, really pretty because I can't see braces. Whatever the reason, you'll know. I'd like to see this, and you'll probably get some feedback. I was like, yeah, okay, that's possible. And then if you're really keen, we can start showing you where in the code base to start looking if you want to code it yourself, or other implementations to kind of copy off some guidelines. And the foundation employees are in a variety of different time zones, as I can attest in being the
you are
the furthest closest to the dateline. That can certainly pop on our channels and sort of ask.
Yeah, so I think to highlight there, you said it's innovation to have the insight that we want the trace to have a YAML output, not just JSON, and it's innovation if somebody wishes to contribute that, and it's innovation of the foundation to then have a look at that code contribution in order to be able to merge it. So any really short concluding words about how do you see migration and innovation fitting together? You have probably 30 seconds to give a couple of concluding words.
There's been a lot said on migration already. I guess the key is to make it easy. I guess how I describe with the load data, that's, if you need to dump out and re-import, you certainly want to know, where are the discrepancies, whether that be, character set and they can pop into an errors file or not. But, we want to make it easy. We want to identify the differences that make migration harder and whether we can fix those by implementing a new feature, a new function.
Great.
A better way of doing it.
I think those are great concluding words. Making innovation easy. A lot of easy things make for a good, innovative MariaDB server. So thank you, Daniel Black. Great presentation and good insights.
Welcome. Thank you.
Now for a look forward by Sergey Golubchik from the MariaDB Corporation, 10.5 and beyond.
Hello, welcome to the presentation about 10.5 and what's coming next. Let me introduce myself. My name is Sergey Golubchik and I was adding features to MySQL since 1998, and since 2010 I'm working on MariaDB. Now I'm a VP Server Engineer in MariaDB Corporation and a board member of MariaDB Foundation. So 10.5, main facts about it. We started working on 10.5 in May 2019, and in about a year we released a first J release, and as usual it'll be supported for 5 years, so it'll reach end of life in July 2025. In my opinion, the largest 10.5 feature is column store, so let's talk about column store. Column store is a storage engine for analytical queries. Imagine an analyst sitting at his laptop and cutting and slicing the data in various ways and grouping them and joining and ordering and stuff like that. This usually means static, mostly read-only data. This means complex select queries. And that means that you don't really know in advance what the analyst will do. So you cannot actually pre-create indexes in advance to optimize for his queries. And this is exactly the use case for column store. A bit of a history. Column store is not a new engine that we just quickly whipped up last year. It was under the name InfiniDB. It was developed by Calpon since 2000 to 2014, according to Wikipedia. And under the name column store, it was developed further by MariaDB Corporation since 2016. And now it had reached a step where it could actually be added as a pluggable storage engine into MariaDB Server. A word of caution, because in MariaDB, plugins can have independent maturity levels. MariaDB 10.5 is GA, it's stable, but column store is at the moment only Gamma, but it's still quite usable and hopefully it'll be GA quickly. So what is column store? As you might have guessed, is a columnar storage engine. That means that values for all columns are stored together. All values for one column are stored together, as opposite to, for example, in a DB where all values for one row are stored together. This works very well for analytical workloads where the tables are often generalized with hundreds of columns, but you only want to look at a few of them. If you store separate columns separately, then you only need to read the data for those columns that you're interested in, significantly reducing the I/O and making the queries faster. Also, storing all values for one column together makes compression a bit easier. So 10 times compression in column store world is not something unheard of, it's typical. And also, column store has some kind of indexes or index-like structure for those columns. You don't need to create indexes explicitly. In fact, column store doesn't even support explicitly created indexes. It kind of automatically indexes everything all the time, which is exactly what you need for analytical use case, because you cannot pre-create indexes in advance, as I just said. So column store fits this one very well. You can modify your data with insert, update, delete, but as it's again usual for analytical databases, column store has a fast bulk data loader, which allows you to quickly load a huge amount of data into column store by passing a SQL interface directly into column store. And as it's not very usual for analytical databases, or was not, column store can easily scale horizontally. If you have lots of data, more data than your workstation can handle, you can add another storage node and then yet another storage node, and then you have a storage cluster of nodes that your MariaDB server will be talking to. Also, you can add another MariaDB and yet another MariaDB, many MariaDB nodes talking to the cluster of storage nodes, so you can scale both on the MariaDB level and on the storage level. Column store is a really huge thing, and it deserves a talk on its own, and deserves many talks on its own, and we don't have time for that. So this is the URL to the knowledge base. Read the manual if you want to know more about column store. Another new storage engine in 10.5 is the S3 storage engine. It's designed for inexpensive, reliable storage of archival data. Like, imagine you have some financial transactions, or I don't know, some visits to your websites, user clicks, ads, advertisements that you show, and you store your current data locally in your data center, and then you also need to provide high availability, redundancy, and stuff like that. And data for previous months you can upload into the cloud, into Amazon S3, for example, and then you'll have rather inexpensive and quite reliable storage of your archival data, and you can work with your infrastructure on your actual data that you modify all the time. So, as again I just said, S3 storage engine stores data in Amazon S3. It can also use any other compatible storage that uses S3 compatible API. The data in the S3 engine are read-only, so after you upload the data into S3, you cannot change them anymore, but which is fine because those are historical data that do not change. And S3 allows shared access to the data. You can have many MariaDB servers accessing the same set of S3 buckets, so you don't need to duplicate the data if you want to access them from multiple places. Again, there's a knowledge base page about S3 storage engine. There's also a Percona blog about it. You can check both if you're interested. Now, what new SQL features were added in 10.5, well, on SQL layer? I'll start with small and simple features, and then I work my way to the more complex ones and that I explain on following slides. First, database can now have comments. It was a contributed feature. There was a pull request. It's not something we developed internally. You can create and alter database with a comment clause, or you can use show create database to see the comment. All the table can now rename columns and indexes. That also should be pretty easy, pretty clear. Select uses set operations like accept and intersect since 10.3, and now they can also support the all qualify, not only distinct. This is SQL standard feature, and it was developed again not internally but during the 2019 Google Summer of Code project. Google Summer of Code student implemented it for us. Another 2019 Google Summer of Code project was insert returning. With returning clause, you can return a result set from insert that contains the data you have just inserted. It's particularly useful if you insert lots of rows and you want to know generated auto increment values. You just add returning and the auto increment column name, and whatever auto increment values were generated, you can have them as a result set from your insert. If you use recursive CTEs to traverse graphs, you definitely have faced the cycle avoidance problem. Now it can be solved more robust and faster with the cycle clause. And if you use application time period tables, we now support with overlap standard constraint. And more about it on following slides. So, cycle. This is an old example of the recursive CTE from our recursive CTE knowledge base page. If you want to see the complete example, go to the knowledge base, but it basically has a table of the US city names and another table of bus routes between those cities. And this recursive CTE shows all the routes starts from New York. So first select New York, and the second one recursively appends the current city to the current path and locate condition it rejects cities that are already present in the path toward cycles. So there are a few problems with this approach. First, as you can see, after finding a perfectly valid route from New York to Boston, it also suggests to go from New York to Boston via Washington, which nobody really does, 3 times as long, and so it's kind of a useless path that we don't really want to see here. But this is a minor annoyance. The major problem is there's a bug here in locate. Let's say we also had, besides New York, Washington, and Boston, we also had Moreno Valley, California, and Reno, Nevada. This locate thing would find substring Reno inside the city name Moreno Valley. It would think that the bus has already been to Nevada, even though it hasn't. So this is just plain bug, and this is the old version of this recursive C from the knowledge base. In the latest version I fixed this bug, but there is no completely foolproof way to fix these string searches. They are inherently buggy, inherently problematic, and also they are slow, particularly if you have long paths that do the string searches all the time. This is just slow. This is what 10.5 fixes. See, this query region, it removes locate completely and uses cycle clause. So it doesn't invent any more creative ways to go from New York to Boston via Washington, doesn't show this long path after it has found the short path, and also it's faster and it's bug proof as compared to the string searches. Now, as for without overlaps, let me first describe the use case here. Imagine there's a hotel booking system. So that's a table, it has hotel rooms, it has guest names, his check-in and check-out dates. And then we insert some data here. Alice moves in, checks into room 11 in October 1st and checks out on October 3rd. Then Bob will take room 12 from October 2nd to October 5th. And then Carol will take the room 11 after Alice checks out from October 3rd to October 7th. And then Dave will check room 12 from October 4th to October 6th. And now if you're following the dates, you would have noticed that there's a mistake here because Dave cannot check into room 12 because Bob didn't check out yet by October 4th. And with 10.5 we can make the database to check this constraint for us. First we need to declare this table an application time period table by creating a period of those dates. This way we tell the database that those two dates they consider a time period. This was possible in 10.4. In 10.5 we can add a new constraint. It's a unique constraint for room numbers and a period without overlap. That means that either periods should be without overlaps or room numbers should be unique. If 2 rows have overlapping periods, then those rows should have different room numbers, which is exactly what we need here. And if you would try to do those inserts into this table, you would get a duplicate key error, which is basically exactly what we need here, because Dave can check out in the room that Bob didn't vacate yet. Now, one of the most user-visible changes in 10.5 was the splitting of super privilege. Super is a quite historical privilege that existed for maybe 20 years. Over time, it accumulated all the different commands and activities that didn't quite fit in any other privilege. So it became a security nightmare because you cannot grant anybody fine-grained access to do something. You have to grant the whole super that allows the user to do lots of kind of things. So we finally decided to bite the bullet and split the super into logically grouped activities, and every activity got assigned a separate privilege. For example, binlog monitor allows you to do show commands related to binlog, like show binlog status, show binary logs, show binlog events. And set user allows to change definer of stored routines and views. And I'm not going to describe every single one of them because, again, you can just check the knowledge base here. There were features that we have added to add more visibility into what MariaDB is doing, what's happening internally. And one of those features that was requested for quite a while is better performance schema support. More MySQL compatibility in the area of performance schema. We have added a lot of new performance schema tables to 10.5, making it basically MySQL compatible here. So if you have an application, some kind of monitoring application needs performance schema, it'll probably work with MariaDB out of the box. There are a few tables that we don't support yet, and we are working on supporting them. I'm not going to talk more about performance schema because there will be Valery Kravchuk's talk about performance, and he'll talk about performance schema in MariaDB. Also, we've added more tables to performance schema through information schema, providing more visibility into what thread pool is doing, and more status variables that describe various aspects of InnoDB, like memory consumption, net logs, again, exactly for this very reason, to provide more visibility into what InnoDB is doing internally. So now from performance schema, let's segue into performance improvements. Those are important performance improvements on the SQL server level. So until 10.5, you would do an order by, I don't know, varchar 300, then every sort key would take 300 bytes in memory, and if you use UTF-8, it would be 900 bytes. And starting from 10.5, sort keys would only take as many bytes as the actual value takes, which means that usually MariaDB would put a lot more keys into one sort buffer. It would need to write much less data to disk, so the queries will be faster. How much faster, that actually depends very much on your application. In our benchmark, we have seen queries getting 5 times faster and 10 times faster and 10% faster, or not faster at all. It depends on the data type you're using, you're ordering by, on the character set. As I said, UTF-8 will get better speed improvements. It depends on number of rows on the table. It depends on how actually long your string values are. And also depends on what you're doing, what your query is doing, because if you do select star from a very huge table, then most of the time the server will spend sending data to the client, and any file sort optimization just won't be noticeable on that time. Another optimization affects everybody who needs to return numbers from the database, which I think is just pretty much everyone. In our simple select number from T1, we've seen 11% speed up by optimizing, removing unnecessary character set conversions for numbers. Now we've replaced PCRE, regular expression library, with PCRE2, and if you check regex engine machine speed benchmark, if you go for that, you'll see that PCRE2 could be sometimes slower. When both PCRE and PCRE2 are fast, then PCRE2 can be a bit slow, but usually it's faster. Sometimes can be 7 times faster if you do lots of OR operators. Depends on your regular expression. And by the way, note that all those improvements, they affect both single thread performance and multi-thread performance. It's what happens quite often, that if you want to improve high concurrency multi-threaded benchmarks like sysbench, then single thread performance, it basically goes down the drain. This is not the case here. All those improvements, they both improve single thread and multi-thread performance. And also parallel replication now is optimistic by default. It means the thread the slave will try to parallelize as many transactions as possible, not following any more master concurrency. The slave will have a much easier time to keep up, even under load. So these were performance improvements on the SQL layer. There were also lots of improvements on the InnoDB layer, and I'm not actually going to explain them all. I just listed some of them, because there will be another talk by Marko Mäkelä who will talk about scalability improvements in InnoDB, and then he'll be talking about all those InnoDB improvements. So just watch his presentation if you're interested. Now, there are a few features that don't quite fit in any of the previous slides, so I'll just list them here. All the binaries were named to use a consistent naming pattern, MariaDB-something, like MySQL dump was renamed to MariaDB-dump, and MySQL _upgrade was renamed to MariaDB-upgrade. But there are symlinks to all names, so all the scripts and all applications will continue work as before. You don't need to change anything. But the plan is in the future to make those symlinks optional. So this is interoperability feature. If you don't want to install the symlinks in future MariaDB version, then you will be able to install MariaDB and MySQL in parallel if you would ever need to. We've added a new data type called inet6, which stores, not surprisingly, IPv6 IP addresses. Note that it doesn't just store them in strings, it stores them as 128-bit byte numbers. So the first 0 that I've inserted, it's stripped, and the number is printed in the IP address is printed in the canonical form. You can also see actual bit value, numeric value of the IP address, IPv6 address if you want to. But what's actually important here is that we didn't just add a new data type, we added a new plugin type, a new infrastructure for pluggable data types. So now it's much easier to add new data types, and you'll see more more pluggable data types added in the future. You can add yourself more data type plugins if you need to in your application. If anybody still downloads binary targals, you'd appreciate that they become much smaller. And if you're using system versioning and you care about performance, then you probably partition by system time to keep history separately from the current data. And typical partitioned table look like it has one current partition and one history partition. Because this is such a typical use case, we simplified it and you no longer need to specify partitions explicitly. The MariaDB Server will do it for you, you just need to specify tables partition by system time. If you want to have more than one history partition, you can do that too by just specifying the number of partitions, which is particularly useful if you want to rotate history by time, for example, like in this table structure, where every month of history is stored in a separate partition. There are other features, but we are running out of time, so I'm moving to the beyond part of my talk, beyond 10.5. And beyond 10.5 is, next release version is 10.6, so let's have a look. 10.6 facts. The 10.6 development branch was created in May 2020, but actually some of the features were in the development long before that for many months already. So it's not like we just only started working on 10.6 4 months ago. Now, I don't have a crystal ball, I don't know what will happen in the future, but if you look at other MariaDB releases, then they usually become GA somewhere in May, June, and they are usually supported for 5 years after that. So probably 10.5, 10.6 will be GA in May 2021, and it'll probably be supported until April 2026. But of course, I don't know. As usual, development happens all in public. So this is our Jira. You can search for yourself. You can search for fixed version equals 10.6 and see all the issues which were considered for 10.6. There are already, as you can see, almost 200 of them. So we definitely won't be able to do them all. And I'm not going to talk about them all. But this is my personal, highly subjective top 7 list of all those 197 features. The first one is, of course, the cross-engine alter table. This is something I wish we had quite a long time ago, and lots of users wanted it. It's when you alter a table and you can see it still continues to be writable until the alter operation finishes, and that's independently on what kind of alter you do. Even if you do it between different storage engines, you can still keep using the original table until the alter operation is done. Second one is atomic DDL. I don't quite need to explain that. I think atomic DDL is pretty clear. And it's a feature that you don't usually need. You only need it when you have a crash exactly during DDL. But when you do have a crash during DDL, then things can get pretty ugly. There could be data corruption if you are really unlucky. And with this MDEF implemented, then you cannot, because no matter when the crash happens during DDL, it cannot have data corruption or data loss. Keep sending metadata in binary protocol. It would be useful for anyone who's doing short selects, like point selects, and using a relatively modern connector that uses binary protocol. Because in this case, the metadata is sent twice, and it could be up to 3/4 of the actual data. So by skipping unnecessary metadata, we can send a lot less data over the network, and again, have the whole query round trip much faster. And another interesting feature would be adding support for JSON table. If you don't know, it's presenting JSON as a table, so that you could do select from and then JSON. It's a SQL standard feature, and Oracle and MySQL both have them, and other databases. And users were requesting it. We are planning to have it in 10.6. Don't open partitions included by partition pruning means that you'll appreciate that if you have a table with lots and lots of partitions, maybe system version, I don't know, and you only need data from a few of them. Currently, MariaDB opens them all, but not open, I don't know, hundreds possibly of partitions that you won't be even looking at. You can shave a lot of time from the query execution. Executing a DB crash recovery in background means that, if you have a crash and then after the crash, MariaDB will start faster, it'll be serving queries earlier, and it'll continue in a DB recovery in background. And the last one is, remember I just had a query, I just had a table structure with partition by system time, interval 1 month, 12 partitions. I get 12 partitions, and every new month of history would be going to the new partition. With this, when this feature would be implemented, I wouldn't even need to create 12 partitions, because every new month, Maria would automatically create new partition for the history. So it would make managing of partition system history tables much faster, much easier. But 10.6 is not only about new features. About half of the tasks are about refactoring. They're not generally user visible, but they improve code stability, they reduce number of bugs, improve maintainability, and quite often they improve performance too. I listed a few examples of those refactoring tasks from 10.6, but I'm not going to describe them. Talk to me on chat, write emails, check Jira if you're interested. So this is what we are working on in 10.6. But hey, you can participate too. You can suggest new features, for example, for us to do in 10.6. But yeah, you need to understand that there are already almost 200 issues, and we won't be able to do all 200 anyway. So if you suggest a feature, it could just happen that it'll just fall below the priority level and just won't quite make the text, won't quite make the 10.6 deadline. Or perhaps your feature will be so awesome that we will decide to do it, absolutely do it at the expense of some other feature. Then we remove some other feature from the 10.6 plan and we add your feature instead. So you can request a feature and you will see on Jira and you will see what will happen. Perhaps there's a feature that you definitely want to have implemented, and we decided that it doesn't quite make the line. You can just go and implement it yourself and create a pull request. As you have seen on previous slides, we accept pull requests, and if it's good, it'll be in 10.6. If you just want to get your hands dirty and help us and implement something in MariaDB, but you don't have a personal itch to scratch, look for beginner-friendly label in Jira. It marks tasks that one can implement without prior experience in MariaDB source code, so even junior developers can usually do them. So talk to us. You can talk to us on Zulip, you can write a mail to Maria developers list. We are always ready to help.
Thank you, Sergey Golubchik. Great presentation, 10.5, 10.6 roadmap. You're calling in from Karpen, close to Cologne in Germany, aren't you?
Yes. Hi, Kai. Hello.
Hello there. So, lots of new stuff that you're talking about. You were mentioning column store there as a highlight. Earlier on in this conference, we've heard about S3. I have a question about the maturity levels. People say that, well, this is not production level yet, but 10.5 is GA. So how can that be? That part is GA. Is it half pregnant?
It is not the production level yet, you're right. I mentioned on the talk that column store is still gamma, but hopefully will be GA soon. And we can do that because every single plugin in MariaDB, they have independent maturity levels. The server maturity and plugin maturity, they basically are unrelated, and you can query corresponding information schema table to see what the maturity level is for every plugin. And there's some safety switch that doesn't allow you to load too risky plugin into your otherwise very stable server. But yes, every plugin has its own development lifecycle, its own maturity, and it can reach GA independently from the server, which allows us to introduce plugins basically anytime, and they can get new features anytime, and plugin might have a more agile development pace than the server itself.
Cool. So approaching this maturity is on a different level, you say, for plugins and for the product itself. Well, what about the timing now here? What can you say and what can you not say about looking at the 10.6 roadmap? What's the process like there?
I can only talk about what happened because I don't exactly know what will happen in the future. I don't have a crystal ball. I cannot predict what will happen. I can look reasonably at the past and hopefully the same will happen in the future. And these are the dates when 10.6, we usually have a new release. New release goes GA usually in May, June, and then it's usually supported for 5 years. So one can reasonably expect that something similar will happen for 10.6, unless there will be some decision somewhere in the middle to change that. For example, for 5.5, as you remember, we decided to support it longer than for 5 years. But currently, 10.6 is in a very active development state, and probably it will be at least until the new year, and then maybe a few more months, and then we'll need to stop adding new features in to let it stabilize until the J time.
So if I'm a code contributor of some of the sponsors of MariaDB Foundation or an external contributor of code, and I believe I have a feature that is of use for everybody else, and I would want to push it, or I would want it to be pushed as part of 10.6. How should I behave? When should I reasonably provide this in order for it to have a chance of being in 10.6?
That depends on, first it depends on how long it'll take for this feature to reach the level where our developers will feel comfortable of putting it into the server. There will probably be a review of the pull request, and usually this is followed by some reviewer comments where the contributor need to make some changes. Well, maybe some trivial changes reviewers can make on their own without bothering the contributor. But all that cycle, and then it might be repeated a few times, but all this cycle should end maybe in January, February, because if it'll meet this deadline, then there's a good reason that there's a good chance it'll miss the feature freeze deadline, and then it won't be in 10.6.
Cool. So,
but of course, again, if it's an independent plugin, then it can be anytime as alpha, because plugins have independent maturity cycles.
Right. So one of the things that that you did not mention in your talk, and that the viewers might not know, is that the security bug reporting is very much handled by you. So, and of course, security bugs and security issues can influence the roadmap. So what can you say about how these security issues work with MariaDB?
We have three ways security bug report can reach MariaDB. We have a security@mariadb.org email that I'm reading, but I'm not the only one. And security bugs are getting reported this way. Then we have a project on HackerOne, and you can report a security issue there, and then you'll get some nice boost of whatever it's called on HackerOne. I already forgot. And then there's also security issues fixed in MySQL and published by Oracle in this quarterly CPU critical patch updates. And we also look there and take security fixes from Oracle, from MySQL. Those that apply, because increasingly they don't apply to my security fixes, they do not apply to MariaDB, or they are already fixed in MariaDB earlier. We have a separate page that lists security issues fixed in MariaDB, and this page on the knowledge base that lists security fixes in Oracle MySQL that doesn't apply to MariaDB, so that when you see an issue fixed in MySQL, you can immediately check whether it was fixed, it was not yet fixed, or it shouldn't have been fixed at all because it just doesn't apply.
Okay, so taking contributions from Oracle is very much equal then to applying the security patches, the CPUs that are applicable to MariaDB as well. Is that the case?
Yes. So every MySQL release, I look at every security issue in the last Oracle critical patch update, and I checked code changes in MySQL, and I see if this is something that's unrelated or it's a security vulnerability fix, and if it is, then apply to MariaDB.
Okay, well, those were clear answers to the questions, and thank you for sharing the roadmap and talking about your favorite features in 10.5 and looking forward to 10.6. Thank you, Sergey Golubchik.
Thank you, and have fun the rest of the fest.
We will. Now for a hardware-related presentation by Krunal Bauskar, MariaDB on ARM.
Hello, welcome all. My name is Krunal Bauskar and I have been driving this MySQL on ARM initiative. As part of this initiative, today we are going to talk about MariaDB on ARM. I'm sure you would find a lot more interesting thing about MariaDB on ARM, and it will help you make a choice whether you should run MariaDB on ARM. So let's get started now. That's a quick intro about me. I have been working in MySQL space for quite some time now. I have also worked with Percona as a PXE product lead, managing all aspects of the PXE, including performance. Before that, I worked with MySQL Oracle team as InnoDB developer and worked on some of the features during 5.7 timeframe. Also in past, I've worked on big data problems at Yahoo Labs, or I've also worked on a project for a startup, which is now part of Teradata. And we made the world fastest storage engine for MySQL and lot more such projects. Currently, I'm working at Huawei as part of open source DB group and responsible for all flavors of MySQL ecosystem, which include MySQL, MariaDB, and Percona. So as I said, I've been driving the MySQL on ARM initiative. So with that quick intro, let's now get started with our talk. So that's our agenda for today. So first we will see ARM ecosystem. We will try to understand why ARM ecosystem is gaining traction and why it is important. Then we will talk about MariaDB and ARM. And then we will see how MariaDB performs on ARM with some performance number. Towards end, we will talk about the state of ecosystem. So with that agenda set, let's get started. So first thing is ARM ecosystem. So I'm sure you have heard of ARM processors. But the context in which you have heard, probably most of us have heard, is mobile or network equipment. Most of our mobiles are powered by ARM processors because ARM processors consume less power. And so they can use the battery better. Now, if you stretch your thinking further, you would observe that ARM processors are also widely used in housing appliances. A lot of housing appliances use ARM processors. If you stretch it further, you would discover that ARM processors are also used in automobiles, especially self-driving cars, and with increasing automobile using electronic circuitries, defense space where the usage or usage of power is important. All these kind of application ARM processors have been gaining traction. Something which is new is HPC. HPC stands for high performance computing. Most of our products like application server, databases, big data falls under HPC. So thanks to the performance per watt, as I said, ARM processors are better at are optimal at consuming power, thereby reducing the cost of ownership. And they are getting more and more powerful with additional computing power that makes them a suitable choice for even use in HPC. Now, something which has changed in past couple of years is few years back, if you wanted to boot a very strong ARM instance for running your HPC application, there was nothing available. But in past couple of years, a lot of cloud providers have started offering ARM instances. For example, Huawei Cloud offer a ARM instance using its high silicon Kunpeng 920 processor. AWS offer ARM instance using Amazon Graviton 2. There's another startup called Ampere, which is trying to develop ARM-based, cloud-ready ARM-based processors under Ultra series. So with options available, developer can now easily port their application to ARM, and user can eventually start directly running their application on cloud using ARM instance. But only having only having hardware doesn't help. So the software also has to be evolved, and that's exactly what we call as ecosystem. Fortunately, in past few years, all major OS providers has been able to provide OS support or OS releases for ARM. Then beyond that, if you look at projects, right, the applications, so most of the applications now are either supported on ARM or work in progress. For example, big data, the Hadoop, which was the base for big data application, is already now supported officially on ARM. Application servers, load balancers, databases are most of them are either work in progress or supported on ARM. Now, ARM Cloud Instance, so the reason why ARM is gaining so much of traction is in ARM is supposed to generate a direct saving of 30% by keeping performance on par. So that has been the motivation or USP why ARM is gaining so much popularity. So strong presence of ARM on data generating device is also going to fuel why ARM should be also used for backend server. So your complete end-to-end ecosystem chain is could be booted on ARM. Now it is estimated that by 2030, most of the HPC application will be running on ARM instances. Let's see, it could be earlier based on how the things evolve. Okay, so that with that, a short intro about ARM ecosystem. Now let's talk about MariaDB and ARM. So fortunately, MariaDB is already part of ARM. MariaDB has been releasing packages for ARM on distros like CentOS and Ubuntu, while there is a work in progress going on to add support for more distros in near future. So we are hoping that almost all the distros, major distros, will be supported. MariaDB not only support MariaDB server on ARM, they have spent good amount of time and efforts to optimize it on ARM. We'll see what some of these optimizations, but as I say, optimization is a never-ending process, so the effort will still continue. In fact, MariaDB was first to add support for ARM. And as I say, MariaDB has a full support or GA, which means all your bugs, whether it's functional bugs, correctness bug or performance bug, will get addressed with the same priority like x86. So that makes MariaDB an ideal choice as a database or open source database to be run on ARM. Now, when you add any additional architecture, you need to face some basic challenges, and ARM is no exceptions. So let's understand what challenges are involved when you port any HPC application to ARM. So ARM is a weak memory order. We all know it's a weak memory order. So to get optimal performance, proper memory ordering has to be used. x86 is a strong memory ordering. So if you are just reporting the code will of course work, but will not get optimal performance. Thankfully, C++11 added a support in its standard for memory ordering, and MariaDB being C++11 compliant was able to harvest this memory ordering support and make optimal use of memory order to get maximum performance on ARM2. Tuning code for ARM. Now ARM is a different architecture altogether. So low level loops or basically code like spin loop, right, needs to be readjusted. I would say readjusted and retuned for ARM processors, because the instructions for pause are different. How much time you want to spin would be different based on the frequencies and all. So accordingly, you have to make sure that code is retuned for ARM processors. So ARM is all about more cores, maybe less powerful, and more. That means more NUMA nodes. So any software that needs to have given with more cores should able to use them efficiently. What I call it to be a NUMA compliant or basically a NUMA optimized software. MariaDB was already NUMA compliant or optimized, since x86 also has multiple NUMA nodes. But additional cores, how to make use of additional core, MariaDB actually have tuned or have solved a lot of scalability issues while working on ARM. And I could say that MariaDB is now completely, or I would, pretty well optimized for more cores that ARM processor throws at it to make maximum or optimal use of these processors. Beyond that, ARM do provide some acceleration instructions in form of neon SIMD LSE. So atomic instructions, special atomic instructions, or optimizations of it. So all these, even with vectorizations and all these things are also provided by x86. But since the code or these are low-level hardware instructions, you may have to write a parallel code along x86 for ARM purpose too. So making sure that you tune all such code snippets and enable them for ARM from optimization perspective is also important. ARM has a different cache line requirement, so making sure the cache lines is adjusted. Alignments, memory alignment hints could be needed. There could be pipeline differences. A code which could be hotspot, which is not hotspot on x86 could be turned out to be on hotspot on ARM. So making sure you understand discover such code, retune them is needed. And switching to use hardware optimized support. So there are few functions which hardware can also do. For example, very good example of this is checksum. So when x86 also provided such functionality where it could compute some of the things directly at hardware level and they're faster. And the same support is also offered by ARM. So making sure that you discover such code and get it ported and use the relevant functions from ARM hardware architecture is important for making software performance optimal. So these are few challenges that any HPC software will have to face, and of course MariaDB has already faced. So if we look at the complete solution, all the issues, then you could look at, this is a partial picture that we are trying to provide. MariaDB have addressed almost on all front, some optimization has been done, whether it's memory ordering. So memory ordering has been taken care of. We just talked about one of such challenge. NUMA scalability, even on NUMA scalability, like spin lock optimization, timer counter optimization, cache line sharing, all such more optimizations has been taken care of. Whether it's use of neon, even that has been taken care of, moving to atomics so that it is able to scale correctly. Use of checksum, we just talked about the checksum example, making sure the hardware checksums are used. So when MariaDB optimized MariaDB Server for ARM, they made sure that the optimization is not only done in one direction, but all aspect of optimization for HPC softwares are taken care of. And the result of this is the complete upliftment on all scenarios, or I would say all use cases. You could see that MariaDB Server on ARM performs better. So all these good optimizations, let's understand how they are going to help. Okay, so only one way to find out is by benchmarking. So we will try to look at some of the benchmarking numbers with this. Before we get into the real benchmarking, let me introduce you the cost performance model. I'm sure you might have heard something similar to this in past, but let's talk about it, what I meant by a cost performance model. If you boot an ARM instance and if you boot an x86 instance, roughly with the same size of computing power and memory, you would see that almost on all cloud provider, ARM instance provide a decent saving, anywhere ranging from 20 to 50%. So that is expected because that's the USP of ARM resources. So of course, the idea now would be that can we leverage this cost saving and still get improved performance? So if I can run the same software on x86 with the same configurations and on ARM, and if I could still get on par performance, I could say that I have achieved a 40% saving. Okay, so this is the existing model, but there are challenges. Right, the challenges are CPU frequencies. When you compare two instances of ARM, like here, if you compare on Huawei Cloud, the Kunpeng ARM instance is 2.6 gigahertz, while the respective instance of x86 is have a base frequency of 3.0 gigahertz with a turbo frequency of 3.4 gigahertz. So these frequency differences make the comparison challenging or basically not on par. Beyond that, Intel has turbo mode, which means on lower scalability, Intel is always going to score because it is going to use its turbo mode. Now, CPU generation differences are also there. Now, Intel itself being in race for quite some time now, it has its Broadwell, it has Skylake, it has Cascade Lake, and more such things. So there are CPU generations differences. Now, x86 cores have physical core. There's a concept of physical core versus HT core, what we call as hyper-threaded core, and what cloud provider provide you is vCPU, right? So there are these differences. There could be NUMA arrangement differences. NUMA make a difference, and with increasing cores, more NUMA nodes will be there. There could be memory differences. Scheduler, what I've heard is with Linux kernel 5.x, there is improved support for multi-NUMA architecture. So that's another thing to consider. So with all these things in place, it's important that we can't directly compare, or it would not be an apple-to-apple comparison just for purpose of cost saving. So we developed a different model, or we just proposed a different way of looking at it. What if we could say we could keep the cost constant, and let's analyze if we can get more throughput on ARM, thereby turning into more TPS per USD. So if I put it more formally, if I have X USD to be spent, what I'm going to do is I could get M ARM resources and N x86 resources, of course more ARM resources. Can we get increased performance from these M ARM resource? So for cost constant with ARM resource, I'm getting more performance, thereby it is increasing my TPS per USD. I put it more into form of definition. Given the on-par cost of both the resources, can we exploit ARM variant to its fullest benefit and get better performance when compared to x86? I think that's fair enough to consider. So let's understand whether we can apply this model and then analyze how ARM performs with respect to x86 using MariaDB as an example. So this is just a quick example of if you try to boot a VM on Huawei Cloud, almost of the same cost, x86 and ARM, you would discover that, and the memory is also same. For the keeping all other configurations same, it typically looks to be that the computing power is almost double. Okay, so there are 2x more core. I shouldn't say computing power because there is a frequency differences, but let's assume that you can get almost double the cores or 2x more core for ARM. Now these extra computing power is surely going to help you scale better on ARM versus x86. The difference looks to be 2x on VM. With bare metal, this difference further increases. So we'll see, with how this particular extra computing power is going to help us. So this is a typical setup that we will be using. So this is all testing is using Sysbench. So most of us would be familiar with this. We would be using data which is of 69 GB in size. We will be testing it on two things. One is a CPU bound workload where we will provide enough buffer pool, and an IO bound workload where we will provide a lesser buffer pool. Redo log is good enough too. We would be using two different versions of MariaDB, 10.4.13 and 10.5.5. So 10.5.5 has some performance regression on the flushing front. So which is actively being fixed by MariaDB team. So just for a fair comparison, we will use one older version where this particular regression is not present. So we'll get a good idea of how ARM is performing. And we'll also see the result in 10.5.5 where also ARM is performing. So test scenarios, we will look into Sysbench, point select, read only, read write, update index, update non-index. Machine configuration, we have used a bare metal and we have applied the CPM model. So for the same cost, we could get 28 HT core of x86 and 64 cores of ARM. Okay, so that's the normalization done on using CPM. And storage, we have kept the same storage for both of it. The IOPS are almost or comparable on both of the storage. So that's the short, that basically by keeping all the other configurations same, only by changing the computing power, that would make it easy to evaluate whether ARM really perform. Okay, so with that, let's see the results. This is MariaDB 10.4.13 workload, CPU bound workload. The the blue line represents ARM and red line represents x86. As you could see, almost on all use cases, ARM continue to perform better than x86. Importantly, with increasing scalability, the difference of performance further continue to grow and ARM continue to surpass after some point. In fact, for read-write workload, the difference continue to be better with significant margin with the ARM. And even for read-only workload, bearing some small crisscross, we could see that ARM has been able to perform quite better on all the use cases. Now that's CPU bound. Let's talk about what about IO bound. So IO bound also present the same picture. As you could see, for all IO bound workloads, ARM, which is again a blue line here, continue to scale better and surpass or beat x86 on almost all front, including read-only and read-write. So this is MariaDB 10.5.5. As I said, MariaDB 10.5.5 has some performance regressions, which are being actively fixed. But I thought it is worth adding the results. And as you could see, even with this, ARM continue to beat x86 with increased scalability. So again, one thing which is prevalent is that on all these workloads, ARM scales better. Thanks to the extra computing power that is present for the same cost, that is making it scale so better versus x86. TPCC, so this is also gaining quite a lot of traction, or people do use TPCC also for a lot of validation. So I thought I will also add this results just to check how it does. And as expected, ARM continue to perform better than x86 quite significantly with increased scalability. Even for lower scalability, difference is marginal. I would not say it's a huge difference. So difference is marginal. And once a scalability point cross, then ARM just picks up and perform almost double, doubles the throughput compared to x86. Okay, so all these numbers, but then eventually probably we want to put them into some numbers using which we can justify the cost saving. So this is just an example. I have assumed the cost of the machine somewhere about 800 USD, and then I tried calculating TPS per USD. So I'm using one such data point, 1024 thread update index use case, and this is with 10.4.13. We use both CPU and IO bound. If you look at the numbers, then the TPS, that is transactions per second, given for ARM is always higher than the transactions per second for x86. Now that effectively means the TPS per USD is of course better for ARM, and that directly translate into a saving, because for the same cost I could get more work done from ARM versus x86. Now, typically, if you want to put it in another way, I would say there's a point when you would hit a threshold and you will have to take a decision that, well, I have to increase my computing power. So you have two options, right? So either you can go and buy a bigger x86 machine at extra cost, okay, and get your performance scaled, or you could simply keep the cost same and switch to use of ARM and still get a better performance or increase performance. So that way it directly translates into a cost saving. even in form of clusters. If you have a master slave configuration, then of course you would find out there too, if you are booting a 5-node cluster of x86, maybe you'll have to boot a 4 or 3 node clusters of ARM, and which effectively will generate a significant saving. So from all these experiments, it is very much clear that MariaDB on ARM is a cost-effective solution as compared to the other flavors. So with that, let's talk about the state of the ecosystem, because when user adopt a software, he needs to also make sure that the ecosystem is up and running. So that's a quick intro about ecosystem. As you could see, the green blocks are already present on ARM. So server, of course, is there. Backup is inherent tool of server, and so is the cluster solution, whether it's Galera cluster multi-master solution or Binlog. They are part of the MariaDB default server. Things which are in red are not yet part of the ecosystem or have official packages on ARM, but they do work. For example, a few days back, someone from Percona actually compiled PMM or Percona Monitoring and Management Tool on ARM, and was able to compile and get it running successfully. Now, with community support, we can actually make sure that all other remaining components also are made available on ARM in form of official packages. So the question is why we aim for completion, because if you are running part on, of course, you can still run part of these components on x86, because anyway, they will talk MySQL protocol, and they can communicate with the server on ARM using that protocol. But having everything on on ARM would help you get significant cost saving. So I think that is the reason why we should aim for completion. There are other supporting tools of the ecosystem. Like for example, if you are running on Kubernetes, it is available on ARM. If you use VTest for sharding, then probably it should get available on ARM. So with community support, if we start asking, then respective organizations which own that tools or have been developing that tools could make them officially available on ARM. Same with migration tools. So that's why I think the community support is very important for upliftment of this ARM ecosystem. Whether, like we just talked about PMM, there's a Jira ticket open for max scale packages. So go ahead and like it. MariaDB will surely consider it if there are more community interest on making max scale packages available on ARM, connectors on ARM. As I already talked about distro, for distro we are already talking with MariaDB organization, and they are going to add more distros beyond CentOS and Ubuntu. So I think this is going to, community support will always help. And as I say, development still continues, right? So MariaDB, ARM is on their mainline plan. So they do consider ARM compatibility while they develop any new feature. The DB ARM community is growing. They have contributed a lot more performance patches, bugs, making sure that ARM64 wider hardware compatibility is possible, because ARM is an open architecture. Lot of companies develop their own ARM processors using the main design. So making sure that the software runs on all these ARM processors. And if you have any issues and if you wish to join or contribute back to MariaDB on ARM, there is a dedicated channel on community chat of MariaDB now, which is called MariaDB on ARM. So I'm going to end this talk leaving you with a message which says, let's make MariaDB great again on ARM this time. We all know MariaDB is great on x86. We are just saying that let's make it great again on ARM this time. Hope you all the community people would be able to support this. And next time when we talk about it, MariaDB on ARM would be the best open source DB available. Thanks for attending. If you have any questions, you can of course put it over Twitter. I have also an active blog. There's also GitHub. You can find my contact details also. So if you have any questions, of course, you can ask on the channel also and post it to me too. Thank you for your time, and thanks for attending the talk. Thank you.
Thank you, Krunal Bauskar, calling in from Pune, Maharashtra, India. Hi, Krunal. How are you?
Hello, all. I'm good. Thanks, Kay.
Yeah, you got quite a lot of questions on Zulip, didn't you?
Yeah,
That's
it's a
part
new
of.
hot topic.
It's a new hot topic. Yep. So just to start from something really trivial, what's the typical use case for using MariaDB on ARM?
So I think the major motivation is the cost saving. As I pointed in my presentation too, we roughly could get around I would say 100% cost saving, or double the cost could be saved versus to x86. So you could boot up more cores, or you could save on the cost.
Okay.
So I think that's the motivation behind this.
So and what about the setups here? Is it for MariaDB? Have you tried it in replication with Galera cluster? What kinds of cluster modes have you tested?
So it is supported, since it's inherent. I have started cluster Galera cluster, but I haven't not like full-fledged thing. I'm actually testing it at this point in time. So maybe in upcoming days I would blog more about it. So yes, so I presume it should just work fine based on my initial testing. But yeah, of course, we will do a more formal testing and publish about the things about it.
So speaking of formal testing, have you tested, compared like performance-wise MariaDB and MySQL on ARM? We do it on Intel, but have you done it on ARM? And if so, what are the results?
Yes, good question. So yes, we did compare it very briefly. A longer thing is coming up in upcoming days. Again, MariaDB, as it beats MySQL on x86, especially the latest release, the same thing is observed on ARM2. So the pattern is maintained. You don't lose the advantage just by moving to ARM against MySQL.
Good. So if you want to test MariaDB on ARM, what's a typical setup? What should I know about, for instance, which version to use?
So I would recommend using 10.4 or 10.5, probably the latest, since most of the enhancement has been done to during that time frame. Older versions may not perform that well, like the recent checksums and all those things went into 10.5, and we are also contributing to 10.4 or 10.5 time frame.
So you briefly touched upon these other surrounding ecosystem components, load balancing, proxies, and stuff. Is there any community build version of those for ARM? What can we do while we're waiting for official packages?
So what we as a community members are trying to do, as an I am personally trying to take some of these packages, build them, and at least send the steps, right? So someone, as I said, from Percona tried PMM on ARM. So till we wait for it, I think these steps would be useful if you want to try it, and if you are kind of in experimenting mode, you can also build it and deploy it on your test system and start looking into it of how it works.
So good. So what are you working on right now? Like what kind of contributions or improvements are you working on at this moment?
So lately we contributed a patch related to optimizing the spin loop on ARM. It's a low-level feature, differently operate on ARM. So that is known to have improvement up to 12% on ARM. We are working on few more such patches, which are hopefully will have another 4 to 5% improvement. So I think the idea is that we are working on more like a performance patches, so that we can push the performance further. Even for the lower scalability and reduce the latency.
Cool. This is probably the last question, but I still wonder what was your takeaway from Zulip? What kind of questions did you get asked, and what are the key conclusions for those who are not on Zulip right now and just watching the stream?
I think it is more about it's something new. People would like to know how mature it will get. With the recent news of Nvidia acquiring ARM, but then there are cloud providers like Amazon entering in, Apple entering in. So how things are going to evolve, and how quickly or how much should we start investing? When we should start investing time on things, trying things. So I think that's the more of a takeaway from this thing. So I think we are in a very good position now with multiple providers trying to push it. So yeah.
Good. Well, great summary of your questions on Zulip, and good presentation overall. So thank you to Pune, to Krunal Bauskar.
Thank you all.
Our next presenter is Federico Razzoli, Temporal Tables.
Hi, I'm Federico Razzoli, and I'm going to talk about one of the most interesting MariaDB feature, which is temporal tables. I am a database consultant. I'm specialized in MariaDB and MySQL, and I have a preference for open source technologies. I recently started this new company called Database. So let's start by taking a quick look at the landscape of temporal tables implementations. As you can see from this slide, they were implemented by all traditional proprietary database systems, which means Oracle, DB2, SQL Server, and also Snowflake, which is proprietary cloud database for analysts. They are also implemented by open source databases, but with limitations. So PostgreSQL has a complete implementation, but it's implemented as an extension. And this extension is not available, for example, in RDS or in Cloud SQL. CockroachDB has a limited but decent implementation. CruxDB, which is a NoSQL database, well, it's actually built around the concepts of bitemporal tables, but it's not an SQL database. The same applies to HBase, which has the concepts of raw versions, but it's no SQL database, so it's something different. And MariaDB implemented temporal tables in version 10.3. Initially, they were only system-timed version, and in the following version, 10.4, they implemented application time tables. And you can actually use both these features for the same table, and you get what we call a bitemporal tables. We will see what it means during the rest of the talk. So let's start by application time tables. Application time tables are tables having two special columns. I call them temporal columns, but it's my terminology that I use for clarity, and you will not find it in the documentation or in technical articles I've read before. And basically, the versioning is not automatic. When you insert rows, you take care of registering when the validity of the rows begins and where the validity of the row ends, using these temporal columns, which are basically two timestamps, the beginning and the end of the version. So this is an example that we will use for the rest of the talk. A ticket table, which basically represents some sort of support ticket. There is, of course, a primary key, which is an ID column. There is a state, which could be open, verified, fixed, invalid, and when you create a row, it's typically open. And then there are a summary of the ticket and a longer description. But at some point we decide that we want to track the changes to the rows of this table. So here's what we can do. So basically, okay, we do it with a normal alter table. I wanted to highlight that this puts a lock on the table, a shared lock. So basically this means that reads on the rows are possible during the operation of this alter table, but writes to the rows are not possible, and basically they are queued. And the algorithm used is copy, which means that MariaDB creates internally a new copy of the table, so this requires more space on disk. This can be a problem if you have small disks and the table is big. Then we create, as mentioned before, the temporal columns. In this case, they are date-time columns, but they could be also date or timestamp if we prefer. And then there is a special syntax, add period for time period is actually the name of the time period. We can specify any name we like, but I suggest to use time period or something equally clear, because this could be used in some of the queries, and if you use XXX, well, the queries will not be very readable. And then we specify the names of the temporal columns. Note that you can use any storage engine for application timed tables. Okay, here I show a problem of creating a table in this way, because basically the first insert in this slide fails. Why? Because we did not specify the values for the temporal columns. Okay, the second insert succeeds because we specify these values. So this is one reason why this is a better way to create an application timetable. So let's see step by step what we are doing and why. So first we create a new empty copy of the table, which we call ticket temp. Then we alter this copy and we start by creating the temporal columns, but the difference is that now we are adding default values. So for the valid from column, the default value is now, so the current timestamp. For the valid to, well, typically when we insert a new row, it's still valid, right? So in this case, the default value is the highest possible value for a timestamp. Then I create two indexes, probably two bad indexes, but my point is please create indexes because you are going to use temporal columns. So as you can see in this talk, I'm specifying not just what you can do, but what, in my opinion, you should or should not do. I think this is probably more important than just explaining a feature, because basically I'm showing you what experience taught me. Okay, so the next step is modifying the primary key. Why? Because if ID is the primary key, we cannot have two rows with the same ID, even if they are valid in different periods of time. We solved this problem by adding valid to the primary key. Okay, so we drop the existing primary key, we add a new primary key with ID and then valid to. Then we populate the table somehow, and then we run rename table. It's important to notice that rename table is an atomic operation. So basically, we are switching the names, but in no point in time the ticket table does not exist. Okay, so there is no service disruption. It's also important to notice that the operation we made with the primary key should also be made with all unique indexes. Okay. So here I show that if we run a plain select, basically we get not just the current data, but also the rows that are not valid anymore. Okay, this is the default. To avoid this, we add a where clause. I used a syntax I like because I find it more clear, because it's near to what I would say in English. So basically I say where the valid from value is less than now, and the valid to value is higher than now. Okay, so the row is actually valid now. Here I show how to delete rows properly. So we don't really run a delete on an application time table. At least most of the times we will not do this. Instead, we will run an update to change the end of the validity of the row, and we change it from at some point in the future to now. Okay, so from this point on, the row still exists, so we can read it, but it's not valid anymore. So I did this with the store procedure. So here you can see the store procedure in action. We run a plain select, we see the row, we run ticket delete, then we run the select again. The row still exists, but the valid to value changed, and so the row is not valid anymore. So basically, what is the real advantage of creating an application timetable? Well, basically, by doing so, we are then able to use a special syntax that I demonstrated here. So suppose I want to physically delete historical rows, so I'm not preserving the history anymore, because it doesn't matter anymore, right? If our application runs for 20 years, I don't care anymore about what happened 15 years ago. Then I have this special syntax, which is delete from table name for portion of time period name from a certain timestamp to another timestamp. Okay, well, in this case, I also added a where to show that you can do it, but probably most of the times you will not. I suggest that if you do this, the beginning, the start timestamp is always as low as possible. Okay, so it's ideally the beginning of time, because in this way we only delete the oldest data. But if we have data for like starting from the 1999 and ending today, and we decide to delete data from data valid from the year 2000 to the year 2001, well, it is possible that some rows are valid for a longer period of time. So what will happen? Well, these rows are split into two versions. Okay, so there is a version which is older than the period that we are deleting, and a version that is newer than the period we are deleting. And basically, I think this is very, very, very confusing, and we should not do it unless we have very good reasons. The same syntax for portion of also exists for update. Is it useful? Well, yes, it is, because, for example, instead of physically deleting a row, we could mark a row for deletion. So basically, maybe there will be some sort of tool that we read the rows marked for deletions, and it will store them elsewhere outside of MySQL before they can be actually deleted. So let's talk about system versioning. So system version tables. I will use the abbreviation sysver, which is probably only mine. I'm not sure if you can find it in the documentation, but if I say sysver, you know what I'm talking about. Basically, the difference is system version tables are much more automatic. When I insert a row, the beginning of the validity is now. I cannot even change it. When I delete a row, well, yes, I can run delete, but the row is not physically deleted. Instead, an older version of the row is stored. Okay. Well, there is a way to also delete it, but I will not demonstrate it now. So let's back to our example, the ticket table. So this is the original example, so the table is not application timed. So this is the alter table that we can use to make the table system versioned. Again, I wanted to highlight that there is a shared lock and that the used algorithm is copy. And then we simply add the syntax for system versioning. But again, there is a better way to do this, which is basically we create the temporal columns, which I called in this case inserted at and deleted at. These columns are actually also generated columns. Okay, so you can see the syntax generated always as row start or row end. These columns exist anyway, even in the first example. But the difference is if I'm creating them explicitly and I'm deciding their names, I can use them. I can mention them in my queries. Otherwise, I cannot. But anyway, I'm also declaring these columns as invisible, which means if I run a select star, the values of inserted at and deleted at are not returned. Okay, they are only returned if I mention these columns explicitly in my select. You don't have to do this. I'm just recommending to do it, because I think it's more practical. Then there is add period for system time. Then I specify again the names of the temporal columns, and then I specify add system versioning. So the syntax is a bit redundant, but well, you can get used to it. I wanted to highlight you can actually use any storage engine except for Connect, because there is a bug that prevents us to use Connect for system versioned tables, which is probably not super useful, but well, it could have some use cases. So if you're interested, you can follow the bug, because MariaDB has a public Jira. And then there is another bug or feature request, which is support datetime for row start and row end, because SQL standards specify that you can also use datetime. Then I show how to query a sysver table. So what I wanted to highlight is, in the first case, select star from ticket, I get only the current data. I will not get historical data. This is very different from application time tables, right? Then in the second example, I mention explicitly inserted at and deleted at because I also want to see these values, but I'm still getting only the current data. The third example shows how to get the historical data as well as the current data, and I do this with this syntax from table name and time all. Okay, it means get all the versions of the rows from this table. Then I show how to get all versions of the rows. Okay, so well, basically I'm showing how to get the rows that were deleted or updated. So the first two syntaxes are special syntaxes that are part of the support for temporal tables. So as you can see, you can add from timestamp to another timestamp or between timestamp and another timestamp. Well, this is shorter maybe, but you have to learn a new syntax, and if you use an ORM, I'm sure that the ORM will not support this syntax. If you use some special tools, they will probably not support or understand this syntax. So I suggest to use actually the third syntax, which is just plain SQL. I add basically where deleted at less than now, so less than current timestamp. Here I show how to get the history of a particular row. So basically I specify again for system time all, and then I specify where ID equals, and also an order by, because otherwise it will be probably a bit confusing. Then I show how to read rows from a specific point in time. So for example, here the first syntax is actually a special syntax, and it's for system time as of timestamp and then the timestamp. But again, it's shorter, but I'm sure it's not supported by any tool or ORM or anything. So I prefer to use the plain SQL syntax, which is, well, I do it in a way I personally like, so timestamp between inserted at and deleted at, but it basically just means, if you don't understand it, it means where inserted at less than timestamp and deleted at greater than timestamp. Okay. So here I show that you can use what I call a temporal join. So as you can see, I'm joining a table to itself with two different table aliases, of course, but take a look at the where clause. Basically what I'm actually doing is joining the ticket table at a specific point in time to the ticket table to another specific point in time. So without digging into all the clauses, basically what I'm doing is I'm getting the rows that were present on a certain time, and the state was not changed after 1 month, right? So let's say some words about indexes. Okay, if we are using a sysver table, the row and column is automatically appended to the primary key and to all unique indexes. One thing to notice is you probably know that a query can use a whole index or the leftmost part of an index, so its first columns. So basically this means that if the primary key or a unique index was usable for a query before this change, it will also be usable after this change. So the change will not affect negatively some queries. This is actually what I suggested to do explicitly for application time tables. And the reason is, if we don't do this explicitly, well, this will not happen at all for application timetables. Okay? So the final part of the talk is just some hints about what you can or should do. So some things you should do are, or you can do, are, well, a table can be both sysverse and application timed. In this case, we will call it a bitemporal table. Okay, so we can query the rows based on their system version validity or based on their logical validity. We can run statistics on the rows that were added or deleted or changed by year, by month, weekday, day, or whatever. We can run statistics on the row's lifetime. We can get the rows that never changed, or we can get the rows that change too often, because maybe this is a bit suspect, so this indicates that there is something strange. And we can also examine the history of a particular row. Why? Because, well, maybe a row we suspect it changed because of an application bug, so we want to check what actually happened to that row over the time, and we can do it. Some more things that we should or should not do. Well, a primary key, first of all, should never change, because otherwise it will become impossible to track the history of rows. If you are not 100% sure about this, maybe you should create a trigger which basically checks if old ID is different than new ID, and if it is different, it throws an error, so the statement fails. For application timetables, you should never do hard deletions or hard updates, because otherwise you will not have old versions of the rows. If you have to drop a column, you can actually move it to a different table, because in this way you will avoid losing the history. And if you have to add a column, and the column is not often read or written, well, you can consider putting it into a different table, because in this way you will not have a new row which doesn't, a new column which doesn't have a history until now. Okay. And if you run statistics or complex queries that involve temporal columns, well, you should probably add a persistent generated column on these temporal columns, and then add indexes on them to make your queries faster. So what we left out, this is not even a complete list of what we left out, but the time is what it is. So first of all, I did not show any SQL for the last two slides because there is no time. I did not mention alter table. Basically, alter table, of course, can delete part of the history or change it, even worse. So alter table for temporal tables is disabled by default, but you can actually enable it. You can use partitions, one or more partitions, to store the history of the rows. Dumps are affected by system version tables. So please check the documentation to find out how it affects dumps. About replication and binary log, again, please check the documentation for possible problems caused by system version tables. But a last hint, suppose you are using MySQL. MySQL does not support temporal tables. Maybe at some point you want to use temporal tables because maybe you want to allow analysts to inspect production data. What you can do is to attach a MariaDB replica to a MySQL primary server. So you replicate data and then you change existing regular tables in MariaDB from what they are now to temporal tables, system version tables. The main problem with this is that if replication lags, of course, the timestamps will not be correct. But maybe you don't care in some cases, so you can actually do it without major problems, in my experience. So thank you for attending. I hope you found this talk useful. As you can see, it was quite opinionated because I really believe that it's important to comment the features and not just explain what you can actually do. Because what you should do is sometimes very different from what you can do. So this is question time. So thank you very much. Please ask your questions.
Federico Razzoli, Vetabase, calling in from London. Good to see you again, Federico, and your bookshelf.
Great to see you, Kai.
So, temporal tables. You mentioned application time tables, and you mentioned system version tables, and you said you can combine them and have bitemporal tables. But why would I want to use which one of those, and why would I want to use both at the same time?
Okay, this is an interesting question because I believe they respond to different use cases. For system version tables, what you track in the temporal columns is when a row was physically inserted or modified or deleted. With application timetable, what you track is when a row is logically valid. So for example, I could insert a row now and decide that it will be valid in the future. Okay? So the difference is application timetables handle the timing when a row is logically valid, and system versioning tables track when a row is physically written or modified. And bitemporal tables are useful in cases where you need to track both the things.
So you could select country, comma, president, group by country, and then you would get it for any particular moment back in history if you were using application time tables. Is that the case?
Yes, exactly. That's a perfect use for application timetables because if you insert data today, for example, of course, you cannot use system version tables.
And using them at the same time would be necessary because you want both functionalities, both that one of application time and system version. So what's the reason?
Yes, you can do it in a situation where you want your application to be able to handle time correctly from a logical point of view, but you also want to be able to track when the changes to the table happened.
And that you do for auditing purposes, or why do you want to track exactly when it happened?
Auditing purposes is probably the most common thing, because if you see something strange in a table, a row shouldn't have a certain value, or a row was deleted and you don't know why. Well, system version tables help you to kind of rebuild the history of each row and find out what happened.
So during this MariaDB Server Fest, we often compare MariaDB Server to other databases, and not just open source databases, but proprietary databases. So how do you, in the case of temporal tables, how does that comparison work out?
Okay, another great question, because there is a sort of idea that features in proprietary databases are always superior, which is not really the case, and temporal tables are a good example of this, because MariaDB implementation is more complete than SQL Server or Oracle implementation, which I believe, last time I checked, they don't support even bitemporal tables. DB2 from IBM supports them, to be completely honest.
Mm-hmm. So then I'm thinking of another common denominator here is looking at performance questions. So I would be surprised if there were no effect on performance, so it being slightly slower at least. But what's your assessment on the effect of temporal tables on speed?
Actually, in most practical cases, there is no slowdown, because as I mentioned during the talk, when you use system version tables, basically the final timestamp of each column is added to, for example, unique indexes and to the primary key. So basically, if those indexes are able to speed up your queries without taking account of the time, well, they will still be able to speed up your queries taking the time into account. And also something that I couldn't explain during the session for time reasons is that you can partition temporal tables, and you can actually put all the history into one or more partitions. So basically, even if your table is big, you are still able to query the current data and physically query only one partition.
Mm-hmm. So partitioning, you mentioned that. What about archival? So there'll be discussions about S3, and there's the old archive read-only storage engine. So how would you, where do the temporal tables fit in that discussion?
Yeah, so partitioning is useful also for this reason, because when it's time to delete the very old history of a table, you can actually delete one or more partitions, which is a fast operation. And you can move the data actually into S3 using the great S3 storage engine, or you can move them somewhere else. This depends, of course, on you. But the useful thing to notice is, again, use partitioning, because this will allow you to archive your data more efficiently.
Right. So we noted in most sessions here activity over Zulip. So in Zulip, there's a lot of discussion and questions. So did you get any interesting questions that you wish to highlight?
All the questions I got were absolutely great. And if I still have a minute or two, I will answer a question about the use cases.
2 minutes.
Okay, great. So yes, I am aware of at least a couple of use cases where I actually recommended customer to use system version tables. And the reason was that in both cases, the customer had to allow analysts to run queries on production data and see how this data evolved over time. So these customers were using MySQL, not MariaDB. So migrating to MariaDB would have been too much work for this, right? So what we did was adding a MariaDB replica and attaching it to the primary MySQL server. And in this way, the data was replicated and the replica recorded the timestamps when the rows changed. The only drawback that I saw with this is when replication lagged, the timestamp was, of course, inaccurate. But in their use cases, this was not really a problem, and I suspect that in most real-life use cases, it wouldn't be a problem because analysts usually don't need second-precise data, right? They want to see the trends over months or years.
Great, great use case. So thanks Federico for a good session, good question and answer session, and also highlighting an important question out from Zulip. Thank you, Federico.
And thank you. It's always great to participate to MariaDB Foundation's events.
Our next presenter is from China, Pengfei Ma, MariaDB clusters on Kubernetes.
Hello everyone. I'm very glad to participate in the 2020 MariaDB Feast conference. My Chinese name is Ba Pengfei and my English name is Matt, the product manager of Watch Technology. I'm responsible for the product design of Cloud Native Database. Currently, the product has deployed more than 400 nodes in private and public cloud environment. Today, my topic is MariaDB database clusters on Kubernetes. The challenges of MariaDB database clusters on cloud we have been met as following list. First, network solution of hundreds and thousands MariaDB instances over multi-data centers. The most complex part of the public cloud is the network solution. It involves the deployment and scheduling MariaDB instances over multi-data centers. Fortunately, Kubernetes has provided mature and stable network solutions, such as Calico and Frano. Second, cost-effective computing resource. Because each server node runs many MariaDB instances together, the CPU, the memory resources required for all MariaDB instances in a server more than the hardware limitation. Third, portability and easy scale-out. MariaDB clusters be able to deploy multi-released operating system like Red Hat, Ubuntu, Linux, and easy to scale out the MariaDB cluster instance and the server nodes. Fourth, self-healing and auto failover. Because it is impossible to manually operate and maintain huge numbers of MariaDB on cloud. It needs self-healing capabilities such as offline failed MariaDB instance and online new one replaced. Fifth, save disk space. Software and applications are built by Docker engine into image as a running container on Kubernetes. Multi-MariaDB instance running in a server can share the best images due to the Docker storage driver. So let's take a side of Kubernetes architecture. The Kubernetes architecture departs into the control panel and the workload panel. In control panel, it has 3 components: API server, scheduler, and the controller manager. On the workload side, as a Kubernetes and the proxy, we usually use the Docker engine as our container runtime. Both of the components only interact with the API server. We can use the kubectl command to apply the YAML file to tell API server how to deploy our resource, and all the metadata is stored in the etcd. And in Kubernetes, there has so many built-in objects, and it provides powerful resource management. For example, we can use deployment to deploy stateless applications such as PHP admin and MaxScale. If MaxScale becomes computing bottleneck, we can quickly add a replicas number to improve throughput. Daemon set used to deploy system components such as the Calico, because the Calico needed to run in each node to allocate IP address for every path. Stateful set. Stateful set is to deploy stateful service such as MariaDB, the MySQL database. It requires that each pod bound with the PV to persist the data. The job. The job is task management. We can perform a backup task for MariaDB characters, like the cron job or once backup job. The service can automatically discover backend MariaDB instance in Kubernetes and do load balancer. So take a look at an example of using stateful set to create a MariaDB instance. This is a daemon YAML file of stateful set. The advantages of creating pods with stateful set is that each pod has its own PV, and the name of each pod will be prefixed with the metadata field name defined, and plus order number from 0. For example, the first replica name named MariaDB 01, second named MariaDB 02. The YAML file also includes the container image version, the Docker registry address. The storage class provides the PV volume and specific the directory where the PV mount. When a pod to be scheduled, the stateful set will create a new pod to replace, but it retains the original name, network identifier, and the bound PV volume to maintain the pod state. The controller workflow is shown like this. First of all, we preparing a YAML file contain stateful set manifest, and through the kubectl applying it to API server. The controller manager, stateful set is one of the controller manager, by the way. The stateful set controller lists the list of API servers newly resourced and create pod manifest. Newly created pods now stored in etcd. The scheduler chooses the best node for the pod assigned to the node. The Kubernetes watch API server and see a new pod scheduled to its node. It tells Docker, the Docker engine, to run containers. Okay. We use stateful set to deploy a single instance of MariaDB so far, which has certain fault tolerance. However, MariaDB clusters on production environment need high availability, like MariaDB master slave or Galera cluster solutions. The backup strategy, the automatic do the backup and the recovery of the MariaDB instance, monitoring the running database metrics, the read-write split, use the proxy, the max scale to the read-write split. On rolling update, as the MariaDB official released the patch, we needed to do it. Agility means the MariaDB clusters and the server nodes are easy to scale out when we needed more computing and storages. All about features we can be achieved by extending Kubernetes API. We can customize the API objects interaction with a specific controller. For example, the extended API object is named MariaDB cluster. It tells Kubernetes that our MariaDB cluster is composed of 2 MariaDB HA instances and 2 read-only slave instances. The controller inside Kubernetes regularly compares the current MariaDB instance running state with our expected state and find out that there's only one read-only instance running, so the controller would create a new MariaDB instance according to the logical we defined to start a new pod for MariaDB slave, configure MariaDB slave replications to the master, and do the data balance. And the pseudocode is like this. There has a 4 cycle, and the get desired state function returned our expected desired. Get the current state function return the current running status. The recancel function will compare the desired and the current status and do our logical. So the MariaDB cluster controller is like this. We have already extended the API of the MariaDB cluster into the etcd, and we're preparing a YAML file. The YAML file contains MariaDB cluster manifest and through the kube control applied to the API server. Once we have our specific MariaDB cluster controller, the MariaDB cluster controller manager list of API servers newly resourced and create a related stateful set manifest. And the stateful set controller will notifications through the watch and create the pod and the workflow we have mentioned before. The MariaDB class controller, we create 2 stateful sets. One stateful set, the metadata name is MariaDB HA, labeled DB row HA. And the another stateful set named MariaDB slave, labeled DB row slave, and spec the replicas number is 2. And each stateful set exports the service to adjust the backend MariaDB IP. In front of the MariaDB clusters, we can use the Kubernetes deployment to deploy the stateless proxy max scale and configure the master and the slave address on the max scale configure file with the name of the 2 stateful sets. Expose the service respectively. So we can get a MariaDB cluster. We can get a MariaDB clusters composed of 2 MariaDB HA, 2 MariaDB slave using the max scale proxy to carry out read-write split. And let's take a look at the MariaDB cluster internal. Kubernetes pod is the basic scheduling unit. We can run multi-containers in a pod. This container share the network storage, etc. It seems to run on a local host and will be scheduled together by Kubernetes. We package the MariaDB instance, self-developed leader, and the actual program into a pod. When we create a group of pods through the MariaDB cluster controller, the MariaDB instance inside this pod has been started with the read-only start, and their leader components will communicate via TCP protocol. When one of the leader in MariaDB HA labeled pod acquired the lock, it sets the MariaDB instance read-write become the master role. Another pod leader notifies their MariaDB instance to execute the change master command to the pod. This leader component communicates regularly to update its states. Assume that the current master MariaDB instance is out of work. Another MariaDB HA labeled pod acquired the lock. Others leader receive the message and re-execute the change master command to new master instance. After the abort pod restart, the leader component received the event and execute the change master command to the new master. I prepared a demo video on my lab in advance, so let me show you. This is my lab environment that has a Kubernetes clusters. I create the MySQL cluster CRD name instead. You can see I create the MariaDB clusters. We can get the YAM file, the spec, the image, the spec we defined, like the LPS quota, the database resource, the CPU and the memory resource, and the master HA replicas number. And get the stateful set. The MariaDB cluster controller create two stateful sets, right? And the stateful set, the YAML defines the replicas number, the environment, the resource we allocated, and the PV will to mount the directory. So the two stateful set creates the each pause. We execute the pause, the bash, and see that the MySQL container, the leader container, they are into a pod. They show the namespace. And I want to show you the labels tagged to the pod. There has a key label. We label the DB role and label the pod is master true or false. And right now I killed a pod, the 010. We can show its master label is go away, right? The pod is in its state. And then we can hold a second. We can see another pod, another MariaDB HA pod. The label is the field is master equal true. And we labeled the is master equal true as related to the service, the headless service. Then we get the pod status. And right now we execute the master role pod. Going to the bash. Okay. and we'll go to the MariaDB and show the status. That is the master state. That is the master status. And right now, get the port status to see another part. Okay, it's start up right now. We go into the MariaDB pod. When they show the slave status, okay, it becomes the slave, and change mask to the mask now, and use through the service. Okay. Okay, let's go. The Kubernetes, the backup MariaDB instance, the Kubernetes job can start a pod to do one's task. The backup pod container designed to run in Kubernetes as a cron job to perform actual backup of MariaDB to the S3 cloud storage. The recovering a MariaDB instance, we need copy a backup file from outside to a new pod. We can use the init container feature to initialize the MariaDB instance. Before the new pod starts, we copy the backup file from S3 storage to the new pod with the mount PV, and running extra backup program reload the backup files to recover historical state. And there has so many articles introduce how to implementation monitor system. We do not talk too much, while the logs are about a specific event. Metrics are measurable as a measurement at a point in time for a system. On Kubernetes, Prometheus is called native applications. Existing exporters allow bridging of third-party data into the Prometheus. The EFK is very easy to integrate into Kubernetes and supply log elections, analyzations, and exhibitions. The Helm is a third-party tool to deploy apps in Kubernetes, and Helm as like a apt-get or YARN under Kubernetes. It manages a complex collection of applications because our applications usually consist of multi microservices. Helm is very easy to upgrade or roll back the previous version if upgrade failed. Okay, thanks for your guys listening. If you have any further questions needed to be discussed, please feel free to email me or at my WeChat account. Many thanks.
The next presenter is the core developer from MariaDB Corporation, Marko Mäkelä, Scalability Improvements in MariaDB's InnoDB storage engine.
Hello, my name is Marko Mäkelä. I have been working on the InnoDB storage engine for 17 years. I finished my doctoral thesis on concurrent systems on model checking, and I joined InnoBase, the subcontractor of MySQL, in 2003. It was acquired a couple of years later by Oracle, and almost 4 years ago I joined MariaDB and have been involved with development of InnoDB storage engine in MariaDB since then. Today I will talk about scalability improvements that we have done in the MariaDB server, mostly in the 10.5 release. So as a user of a database, you must be aware that transactional logs are something that you control. So the data architecture should be such that you minimize logging conflicts and deadlocks due to transactions. And the rest is the problem of the database server. If you, for example, you are using non-locking reads, in InnoDB reads are non-locking by default, then the transactional logs do not matter. Only if the table is being dropped or something like that, then you will have a conflict with non-locking reads, but the row logs do not matter for read uncommitted or read committed or repeatable read isolation levels. But inside the database we have some concurrency bottlenecks that you may hit, such as if multiple queries are trying to access the same page while the page is being written by some transaction, then the read access to that page would be momentarily blocked. Also, if you have lots of writes, you can have a bottleneck on the redo log buffer or the redo log file. And if your workload is much bigger than the buffer pool, then it could happen that the server is spending a lot of time in evicting pages and writing back changes from the buffer pool before it can evict those pages and get new pages into the buffer pool. To understand how a system works, it's good to follow the open system interconnection model that is used for protocol design or description. If we look at the internet, at the lowest layer we have a physical layer, a transmission medium such as a serial line or Ethernet or Wi-Fi. Those are asynchronous packet-oriented communication media. Anybody who is connected to that network can choose to send something, a packet, at any point of time, and there must be some collision detection, collision avoidance and such things. And as we go up the layers, the bottom layer, the service that is provided by the lower layers is refined by each upper layer. At the top we have the TCP IP, the transport layer, which takes care of retransmitting data and flow control, so that this packet-oriented communication becomes stream-oriented or connection-oriented. Similarly, in databases at the low level we have some storage hardware such as a rotating hard disk or flash memory, also called SSD, or a special kind of flash memory like a persistent memory, which can be written directly from the processor, 1 byte at a time. And on top of the storage layer, the operating system implements a file system layer and a file system cache. Examples would include the ext4 file system in Linux or the NTFS in Microsoft Windows. On top of the operating system and file system, we have the database server process running. And the lowest layer of the database server is the mini transaction layer and the buffer pool, which is a kind of a page cache on top of the files that it is accessing. This mini transaction layer is providing atomic changes to multiple files with crash recovery, so it's atomic and durable. If something is has been durably written by the mini transaction, then it must be recovered. The system must be recovered at least up to that logical time point if it gets killed and restarted. And on top of the mini transaction layer, we have a user transaction layer, which provides things like transactional isolation and multi-versioning concurrency control. For InnoDB, those would be implemented in terms of undo log pages, but other storage engines might use a different approach. For example, RocksDB is not using undo log pages, but it is buffering all changes before transaction commit, and only at commit time it will write the changes to some log. So we have some dependencies and constraints for implementing the atomicity and durability. At the mini transaction layer, we have a concept called log sequence number. It is the logical time of the system. It's basically the number of bytes that have been written to the write-ahead log file. And it's totally ordering those mini transactions that have modified some persistent pages. If a mini transaction is committed and its log has been written to the redo log file up to some LSN, then crash recovery must recover the database to at least that LSN. All the changes must be visible after restart. On top of the mini transactions, we have user transactions, and InnoDB implements those in terms of undo log pages and some system fields in the index pages, transaction identifiers and undo log pointers. And the important thing to notice here is when a user transaction commit becomes durable. Well, InnoDB is writing the undo log before it is making any changes, before the changes become durable. So anything that is done in the transaction will already be done to all the index pages and to the undo log pages. And at commit, only thing that happens is that we will mark the transaction committed in the undo log page. And when that mini transaction for marking the undo log page committed, when that mini transaction is durably written to the redo log, the user transaction is durable. Basic idea is that we follow a write-ahead logging protocol. We must not write anything to persistent data pages before the corresponding change has been durably written to the redo log. This guarantees that the redo log is never behind the state of the data pages, and recovery can be done based on reading the pages that are mentioned in the redo log and checking if those pages are older or newer than our redo log records. There is of course no point to apply redo log records which are older than the page. And to speed up crash recovery, we have this thing called a log checkpoint, which will which will ensure that all changed pages older than a checkpoint LSN have been durably written to the data pages, and then the log checkpoint can logically discard the beginning of the redo log, marking that recovery will start from the new log checkpoint LSN. On shutdown, we do a log checkpoint, and the log would be logically empty after that. So after a normal shutdown, the server startup will recover with an empty log. The next slide describes the flow of a mini transaction. It's the most challenging slide in my presentation, so I must apologize for the level of detail, but I feel that this is necessary to understand the scalability bottlenecks of the InnoDB storage engine. At the left side we have a mini transaction object which is combining a memo which keeps track on read-write logs, also called latches, that the mini transaction is holding. And in the blue entity we have a log of changes to pages. If the mini transaction has before a mini transaction can change an index page or any page in the buffer pool, it must acquire exclusive latch on that page. So no other user of the database, no other thread can access that page. Not even page flushing or checkpoints can access that page. So once we have the exclusive latch on the page, we are allowed to make modifications, and all modifications will be written to the local log buffer of the mini transaction. In the middle we have a number of buffer pool pages associated with the mini transaction. Those ones in blue color, the three blue boxes, represent pages that have been modified. There is also one white page which is a page that has not been modified. The mini transaction could release that page earlier so that it can be accessed by other threads in the database. Also, the memo is pointing to an index latch. In this diagram at the top we have an index latch. It is protecting access to the non-leaf level of the index tree. So if we are starting from the root of the index tree and we are diving towards the interesting leaf page where our key or data is, at the start we must hold the index tree latch to prevent any other thread from changing the upper level pages before we have reached the leaf level. And once we have reached the leaf level, we can release that index latch. Other thing in this diagram is the table space latch. If the mini transaction is allocating or freeing pages, then the allocation bitmap pages, to prevent deadlocks for accessing them, we are additionally acquiring the table space latch. So once we are done with the changes in our mini transaction, we can only commit that mini transaction. The only other way to get rid of a mini transaction is to kill the server. Every mini transaction has to commit. So at commit, the mini transaction will copy the local log of changes to a global log buffer. For that it will acquire a mutex on the log buffer so that it can copy to that buffer and get back the logical position, the end of that buffer, the LSN. And then it can release the log buffer mutex. And after that we have the LSN. We will write the LSN to the fill page LSN header field of each modified page. And if we find a modified page which had not been modified, which was not in modified state yet, we will notice that the oldest modification field in the block descriptor is 0. In that case we will set the oldest modification field to our end LSN and we will move that block to the flush list. Okay, and this after all these steps we are finally allowed to release all the latches that the mini transaction was holding. We will release the latches and we will let other threads to access these pages that we had exclusively latched. And after some time, some thread will write that global log buffer to the redo log file. In MariaDB Server 10.5 there is only one redo log file, IB log file 0. In previous releases you could have multiple redo log files which were logically one file. So basically those multiple files were treated as if they were concatenated together. So we will write the log buffer to the redo log file, and if this was a mini transaction that did a user transaction commit, then that user transaction thread would actually wait for this redo log write to happen. And after this log write, we are allowed to write modified pages to data files. So if the LSN in the page header is not newer than what has already been written to the redo log file, we are allowed to write it to the data file, and we will remove the block from the flush list and reset the oldest modification field back to 0, and then the block is in clean state, and it can be evicted if some thread needs to read another page and the buffer pool is full. Then we have this log checkpoint. The log checkpoint which will ensure that we will not overrun our circular redo log file, and it will also ensure that the recovery will be fast. The log checkpoint will first go through the flush list. If there are any pages in the flush list, it will find the minimum oldest modification in the flush list. This will be chosen as the log checkpoint LSN. We know that everything older than the oldest modification has already been written to the data files. If the flush list is empty, then we know that everything up to the current LSN of the system, the latest LSN, has been written to the data files, and we can choose that as the checkpoint LSN. So the checkpoint will copy the checkpoint will write the checkpoint LSN to a log file header, and that will mark the checkpoint as completed, and recovery would then start from that latest checkpoint LSN instead of starting from the previous checkpoint LSN. And now we are free to reuse the space of the circular redo log file for further log. So you could have like 1 gigabyte log file, and you could have written several terabytes of redo log. But because the checkpoint is never bigger than maybe half a gigabyte, then there is no correctness problem. We can always recover from that log. One more thing related to page writes is that when we are writing a page from the flush list to the data file and the server is killed, it could happen that we get a corrupted page. We could have written the first part of the page, but the tail of the page was still corresponding to the old state. So the page check somewhat detect corruption. What can we do in recovery? We can only apply log to pages that are in some consistent state, corresponding to some LSN. The solution that InnoDB uses for that is a double write buffer. We will first write the page to the designated area in the system table space, and once we have completed that write, we will write the page to the data file, and this ensures that if the server is killed in the middle of a page write, we will be able to recover the page from the double write buffer. A kill during a redo log write is not a problem, because the recovery will scan the redo log sequentially, and it will stop when it detects end of the log, some inconsistency, something that indicates that the last mini transaction was not properly terminated. So recovery would discard the last incomplete mini transaction. It must be atomic and durable, you remember, and it will recover everything up to the start of that last incomplete mini transaction. The next section of my talk is covering the actual improvements that we have done to MariaDB Server 10.5 release to improve, mostly to improve write speed and recovery speed, but also we are slightly improving read performance. So the main thing in the 10.5 release, most visible thing is that we changed the redo log record format. We replaced the old physiological redo log format with a mainly physical redo log format, and we introduced some new special redo log records that allow us to avoid some page writes and reads. If you are freeing pages, we will now write a special log record for that. For example, a drop index operation or a large rollback, which would often insert, that would free lots of pages. In those cases, we would write this special record, and when we come to the page flushing, we will know that this page was actually freed and we don't need to write anything back. So we can actually evict the page from the flush list without writing it to the data file at all. Or if we have this feature called scrubbing enabled, in that case we would overwrite that page with zeros. But normally we would avoid I/O. Similarly, if a page is newly reinitialized by a redo log operation, for example, a page was split and a new page was created and initialized, then for the first write of that page we would not use the double write buffer. The reason is that we are able to recover the page based on the redo log records only. So recovery will not read that page. It will just read the redo log records, and there is no use of the double write buffer because recovery will not need to read the page. And other things that we did without file format changes are an improved group commit, removing some mutex contention on the operation that is ensuring that everything to a particular LSN has been written to the redo log. Also, we introduced a compilation option for persistent memory storage, which allows us to write to the redo log without invoking any system calls. And this new redo log format is easy to pass because it's explicitly encoding the length of each record. This is greatly simplifying recovery and also hot backup with the Maria backup tool. And it also allows us to improve the memory management. Yes, I already covered this. We have fewer writes and reads of data pages. Recovery will not read any pages that were initialized based on the redo log record, and page flushing can skip the double write buffer for those pages. And when we are freeing a page, we will not have to write anything to the data file. We can just discard the page from the buffer pool unless scrubbing was enabled, or unless you were using page compressed tables and you would want to have those holes in your data file in place of the freed pages. And this special record might allow us to avoid writing any short-lived pages, such as when you have temporary tables. It could be that if the temporary table exists for a short time only, then we might avoid all page writes for that table altogether. Faster log writing is mostly thanks to my colleague Vlad Weintraub, who introduced a new type of log for more efficient synchronization of concurrent threads that are attempting to write to the redo log. And when Vlad was benchmarking his work, he noticed that the redo log volume makes a big difference to performance. If we write only a little bit more redo log, the performance with higher thread counts would easily collapse. So this is the reason why we didn't go for purely physical logging for the page operations. For example, if you are inserting a record to an index page with the physical logging, you would have to write log records for updating several fields in the page header, such as the number of records and the next free byte on the page and such things, and also pointers from the previous record to the newly inserted record, and also page directory items. All those are now covered by a special insert record, which basically contains a little bit information that allows us to determine the insert position based on the page contents and then the record payload with as little data logged as possible. And this is actually reducing the redo log volume a little bit compared to earlier versions. And I mentioned this persistent memory interface. It was done by my colleagues Sergei Voitovich and Yevgeny Kosov. They implemented this libpmem interface. Basically, we are writing to a memory mapped file. The redo log is memory mapped, and to make the write persistent, we are executing a cache line flush instruction from the CPU. There is no system call involved for the redo log write. Recovery was mostly improved by the more easy to parse redo log record format. We have the explicitly encoded lengths, so first when we are buffering the records before we are reading any pages, we can just quickly buffer them. We know which pages they are for, but we don't need to parse the payload of those records. We just skip to the next record based on the length that we pass from the start. And we also have a simpler memory management. In the old format, it could happen that some logical redo log record could be bigger than the page size. For example, if you are using 16 kilobyte page size, you could have an individual redo log record that is longer than 16 kilobytes. So you would need some special code to manage those very long redo log records. In the new format, that can never happen. So we can directly buffer those records in buffer pool pages, which is much simpler. And these logical records that we introduced for page operations, they include much better validation of the page contents than we used to have. Previously, in the old recovery code, you could get a crash during crash recovery, but with the new code, you should get a clear error message that the page was corrupted and the log record was not applied to it. So you will know that there is some problem with this particular table space. The next section of my talk covers some code cleanup that might improve the performance of InnoDB in MariaDB Server 10.5. All these changes were done without changing any file formats. There used to be a single master thread in InnoDB that did various tasks such as change buffer merge or purge of transaction history or checkpointing. Over the time, more and more dedicated threads were added, and the problem with that is that those threads are mostly idle most of the time. They are waking up every now and then checking if there is something to do, and this is unnecessarily consuming some memory and also creating unnecessary work for the thread scheduler in the operating system, especially if you have a system with few processor cores. To help that, in MariaDB 10.5, my colleague Vlad Weintraub introduced a thread pool that is used for some InnoDB background tasks. For example, the purge of transaction history is now run in tasks of the thread pool instead of being dedicated threads. And in the MariaDB 10.5 Enterprise server, you can dynamically change the number of encryption tasks, purge tasks without restarting the server, because it's easy to add more tasks to the task queue, and the thread pool would dynamically create new threads if there are many tasks waiting, or it would shut down those threads when they are becoming idle. To improve the performance of purge, we did also some other changes. Mostly it was my colleague Thiru who did those changes. One of the optimizations was that the work is now being sorted by table identifier. If there are multiple undo log records for the same table, then those would be processed in a batch in one purge task. So we would look up the table by the table ID and acquire metadata log on that table, and then process a number of undo log records for that table, and finally release the metadata log and proceed to the next record. If the table by the table ID doesn't exist, we used to be so that for each record we would look up the table in the dictionary cache. If it's not in the dictionary cache, we would attempt to load the table from the InnoDB dictionary table. And of course, if the table was dropped, it is not going to reappear there. So now we are optimizing away futile lookups of already dropped tables. We will only look up once and then skip all the records for that table ID until we find some other table ID, and then we might get that old table ID back again. But anyway, we have much fewer lookups for non-existing tables. One thing that we could improve in the future is to scale this background activity based on the foreground workload. For example, if the server is extremely busy, we might want to suspend the purge activity for a while and let the busy activity continue in the foreground. This is of course not without some trade-offs, because if there is lots of unpurged history in the database, then the things like multi-versioning, reads, constructing old versions of records, or checking if a secondary index exists in the read view, they could become more expensive. So there should be some good trade-off to control the purge lag. One thing that we cleaned up in the 10.5.5 release was deprecation and ignoring of parameters related to InnoDB thread throttling. Back in the old times, like MySQL 5.1, when we only had this master thread doing everything, you could easily have a, and we not only that single master thread, we would also have a single kernel mutex which would cover different things such as the transaction bookkeeping and the log bookkeeping. We would also have a single buffer pool mutex which would cover various operations on the buffer pool. So those would be very obvious bottlenecks that would prevent the system from scaling if you got more than, say, 4 or 8 concurrent connections. And to work around that bottleneck, there were these parameters like InnoDB thread concurrency, InnoDB commit concurrency, and I think it was something like InnoDB replication sleep delay or something like that. And it turns out that currently, thanks to scalability improvements that have been done over time, both in MySQL but also in MariaDB, we actually do scale to a rather big number of concurrent connections. There is no obvious bottleneck if you run an in-memory workload with 1000 concurrent connections or even several thousand on a system that has like 50 CPU cores. So that is, it's kind of obvious that we don't need this concurrency throttling anymore, and it's actually harmful when users accidentally have some old config file that is limiting the concurrency for no good reason. So we are deprecating and ignoring these parameters, and they will be removed in the next 10.6 release. and hopefully the removal of some bookkeeping related to these parameters will also slightly improve the performance. I mentioned this change buffer. It is one thing that was done in a background task. Well, in the 10.5 release we removed the background merge of the InnoDB change buffer. The idea of the change buffer is to optimize performance on hard disk when a secondary index leaf page is not in the buffer pool and we want to insert or delete mark or purge something in that page. We would avoid reading that page into the buffer pool, and we would instead write a record to a special change buffer tree. And later on, when the page is read to the buffer pool for whatever reason, the buffer changes would be merged. And there used to be a background task for merging the change buffer to kind of keep the database in a clean state. But it turns out that this background merge was slightly harmful for performance, and it's also harmful for usage, because if there is some corruption, you know that if InnoDB encounters some corruption, it's not handling that very well. So it would basically just crash the server when doing a change buffer merge at any random point of time. You would have no clue what table it is, what index it is, what is causing that. But now with MariaDB Server 10.5 it's more predictable, because typically the change buffer merge will occur when the current query in the SQL statement is accessing that secondary index. So it's much more obvious if you get that crash. Well, yes, we can still get the crash. That's something that we should fix in a future release to improve the error handling. But anyway, you get the crash and you have a better idea of what is causing that crash, and you can work around it by executing drop index. The server will not crash automatically when you restart it, because there is no background merge for the change buffer. So this is quite a nice improvement in my opinion. And future work, we should improve the change buffer format, make it more logical, remove some limitations. We should actually allow page merges to happen. Like if you are deleting the last record from a page, we should allow change buffering for that. Currently we don't, because a change buffer merge must only operate on one single page at a time. We also cleaned up something in the data dictionary. I mentioned that the purge threads are now using metadata logs. We used to use an InnoDB-wide global read-write log called the dict operation log, or in 10.5 it's called the dict system latch, to prevent the concurrent drop or any other DDL operation while we are processing the undo log records in the purge. But now we have split that. We are acquiring the metadata log instead, so there is more concurrency. And I hope that in some future release we can get rid of the dict operation log altogether, and also get rid of the InnoDB table logs and use the MDL for both. In the buffer pool we did some performance improvement work. I mentioned that the buffer pool mutex used to be a bottleneck. There has been some work over the time. A buffer pool hash table that maps page numbers to buffer pool blocks. For that a partitioned read-write log was used, and maybe even before that the entire buffer pool was partitioned to, in a visual thinking that other threads will use another buffer pool instance while your current thread is accessing this one. But I think that this multiple buffer pool is complicating other things, such as page flushing, and it also makes it difficult to make use of atomic memory access to get rid of mutexes. So in MariaDB Server 10.5 we reverted back to a single buffer pool, and we did some changes to remove some mutex operations. We even were able to remove the buffer block mutex, which was introduced to reduce workload on the buffer pool mutex. Thanks to using atomic memory operations, we don't need the buffer block mutex in those cases where it was previously required. And we also introduced a CPU cache friendly page hash for mapping the page numbers to buffer pool blocks. The latch for protecting the hash array is now part of the hash array on the same cache line. We were not able to do all the performance improvements that were planned for the 10.5 release, so there is something that is going to happen in further releases as well. I will shortly cover those ideas. One idea to improve the writing speed is asynchronous commit. If you have a client that is sending a stream of SQL statements like begin, do this, do that, commit, begin, do the next thing, commit, and so on. Currently, the server would wait for the redo log write to happen for the first commit, and only after that it would start parsing the next statement from the client connection stream. My colleague Vlad has this idea that when we write the redo log for a particular user transaction commit, we would send the OK packet to that connection on write completion, and in that way we would be able to process subsequent statements from that client connection without blocking on the server side. Of course, the client can still wait for the OK packet for its commit if it thinks that it's necessary. Other idea which doesn't require file format changes is that we could recover pages from the redo log while allowing connections from users. Currently, InnoDB recovery, the redo log recovery will be completed before any connections are accepted. Undo log recovery, meaning any recovered incomplete transactions, they will be rolled back in a dedicated thread, but the redo log processing is currently completed before any connections are accepted. And this is something that we could improve. When we improve this, we would also be able to start up, or should be able to start up a database on a read-only file system. You could have a copy of something that might have been killed, and we would do the recovery in memory. We would not write anything back to files, and you would be able to see what is inside those files, or you would be able to dump the data without writing anything on disk. To conclude my presentation, I think that the MariaDB Server 10.5 release is making much better use of the available hardware resources, and it should be scaling from small systems to big ones. We removed lots of confusing or useless or outright harmful parameters, and we made some parameters dynamic. And we improved performance and scalability for various workloads. But as always, when one is fixing some performance problem, it can happen that some other bottleneck is emerging, and it could make some things worse in some scenarios. But for normal workloads that fit in the buffer pool, I think performance is okay. And I find that performance must never come at the cost of reliability or compatibility. So if anything that is unsafe, we shouldn't do such optimizations. It must always be safe, and recovery must work. We have a rigid testing process based on random query generation and using repeatable traces for analyzing race conditions. The RR tool from the Mozilla Foundation is very useful. So I think reliability is covered, and compatibility, we have upgrade testing from old versions, and we try to keep data formats compatible so that you are able to downgrade to an older version in the same series. For example, if you upgrade to, let's say you upgrade to 10.5.8 version in some point of future and there is some bug that you are hitting but we didn't find in our quality control, you should be able to downgrade to the previous working version of the 10.5 series and you will be in business. Some other databases might change the format between minor versions and then it's only one way, and if you hit a bug in that new version then you should have had a logical backup or something that allows you to go to the old version. And we are working on these performance things, so watch out for more improvements in future release. Thank you for your attention, and now it's time for your questions. Thank you. Showing the finger to Oracle. They can't downgrade from.
Thank you. Great presentation on InnoDB. So did you record it outside the cathedral in Helsinki or not the bazaar, or where did you record it?
Oh, sorry, I was seeing the delayed version of the video. Yes, it's my home cathedral, but I try to prefer the bazaar way of coding.
Okay. Good. Yeah, so that was a cultural reference to the Cathedral and the Bazaar by Eric S. Raymond, for those who were not aware of it. So I'm starting by one thing you did not talk about. I remember the expressions online alter table and instant alter table. They're not the most recent features, but still they keep puzzling people. So what's the difference and when did they come into MariaDB's InnoDB?
Well, the history is that in the beginning there was only one way of doing alter table. It was emulated with DML. Basically, the SQL layer in the server would create a new table and run the equivalent of insert select, copying the data row by row, and then rename the table and drop the old table. And there was a MySQL. For MySQL 5.1, there was an InnoDB plugin, which was during the time when Oracle had bought InnoBase, the company, and we were kind of more isolated from the community. At that time, we got this fast index creation, which was originally about creating secondary indexes. Mm-hmm. And in the MySQL 5.6 release, that one was extended and generalized. We got this online alter table, which means that while the alter table is creating a secondary index or rebuilding the table to create the primary key or to add or drop columns or whatever, then during the alter table operation, you could still have concurrent modifications to the table. And that would work based on a modification log. And this was done by me in MySQL 5.6, and it was imported to MariaDB 10.0. Mm-hmm. And then there were some operations such as renaming a column. It was always instant operation. You would basically only modify the metadata, and no data changes were necessary. Also, in MySQL 5.7 and MariaDB 10.2, we got varchar column extension in some cases, and that kind of instant changes we almost always had. But in MariaDB 10.3 we got instant add column, mm-hmm. which is kind of faking some data or changing the data format in the InnoDB data file. So the data dictionary has the newest table definition, but the data file is faking it so that it appears that all the old records already contain this column. And in 10.4, we got that extended with the instant drop column and reordering columns. We also got some further improvements, like if you are extending a varchar column, we removed some limitations around that, which were kind of unnecessary limitations. Also some column type changes. If you are changing from 3-byte UTF-8 column to 4-byte, in some cases we can do that instantly.
Cool. So that's the difference between online and instant. So then moving on to MariaDB 10.5, So what InnoDB feature are you most proud of there?
Well, it's I'm not sure if it can be called a feature, but I'm proud of the improvements we did to the write performance and the recovery performance and backup performance. The new redo record format is much easier to parse, and I think that we are also a bit more robust and using less memory when performing recovery.
Okay, so if that was the pride and the easy question, now let me have the more difficult question. So there have been some performance regression issues related to InnoDB lately. So now what was that all about, and what is your take on it?
Yeah, basically we went for a single buffer pool instance. There used to be a scalability bottleneck around the buffer pool, and in MySQL 5.5 the solution was to partition the buffer pool into multiple instances. And I thought that that is a bad idea, so we went back to a single buffer pool. And then there was some use case where the buffer pool is mostly filled with dirty pages, and pages need to be evicted to make place for further pages. In that case, we had some additional contention when using a single buffer pool. And to fix that, I did a rather large refactoring of the InnoDB buffer pool, reducing the contention on the buffer pool mutex. But it turned out that in an even more extreme IO heavy, write heavy workload, we were actually getting a performance regression. It was not immediate, but after a longer time of running. And that one, I think we have it now in control. I'm working on that. The answer is to simplify the page flushing thread, the page cleaner thread, and the related locking. So often it's the case that when you fix some performance bottleneck, the problem will shift somewhere else. And in some cases, the end effect will be even worse than it was in the beginning. Same thing happened also as part of this buffer pool cleanup. I had to rewrite a data structure, a page hash, which maps page numbers to blocks. Mm-hmm. For that one, I had to come up with a slightly more efficient data structure to improve performance there, because the read-write block implementation of InnoDB was already becoming a bottleneck there.
Okay, interesting. So we've also had a couple of questions on Zulip chat. Did you get any interesting questions there?
Let me check. So mostly it was, I see, mostly from my colleagues at MariaDB. Yeah, something about the replication and InnoDB. I would like to see at least experiment a tighter coupling between InnoDB and binlock or replication.
So how would that work?
I don't have a good idea. Maybe we should do some more prototyping. There was also one thing that one task already planned for 10.5 to reduce the number of fsync operations. And maybe with the persistent memory, this fsync overhead will go away anyway. So that's something that I definitely would like to check to improve the performance when replication is enabled.
Okay, those were very good questions, or very good answers to the questions, and thanks for a great presentation on InnoDB, Marko Mäkelä. Thank you.
Thank you, bye.
Now for a comparison between MySQL 8 and MariaDB 10.5 by Peter Zaitsev.
Hello everyone. Today I'm going to talk to you about MySQL 8 and its difference from MariaDB 10.5, the comparison between two wonderful databases. I have relatively little time for this presentation, so it will be mostly high-level comparison. Now, the first thing, which I think many of you are aware about, is what MariaDB is not MySQL. And while MariaDB started from the same roots as MySQL, and the first versions of MariaDB were very similar, right now they have diverged substantially, and I would rather see them as two great but also quite different databases. You can still run some applications on both MySQL and MariaDB, but especially if you are using the new features introduced in those databases, then portability between them may be harder. Now, me, being a CEO of Percona, which produces a product which can be seen as a competitor to both those products, it would be hard to claim absolute fairness, so I will pledge fairness of being offensive enough to both of those technologies, and you folks probably will disagree with plenty of stuff I will say here, wherever you are MariaDB users or MySQL users. So let's dive right in, as we don't have a lot of time to spend. First, let's look at the development model. If you look at the MySQL, it is developed by MySQL team at Oracle Corporations. Contributions are accepted. Even from us at Percona, we have contributed a fair amount of small patches, though we're not the biggest third-party contributor. All right, but while contributors are accepted, the MySQL practice what I would call the dropship open source model. That means the development is not done in public, but when Oracle chose to do release, the source code appears on GitHub as well. With MariaDB, the MariaDB Server is released by MariaDB Foundation, but I would say what development and roadmap are mostly driven by MariaDB Corporation at this point. Contributions with MariaDB are not only accepted, but they are also encouraged, and development is done much more in the public, especially when it comes to the server side. What is interesting though in the MariaDB case, there are those two entities, MariaDB Corporation and MariaDB Foundation, and I, as an outsider, find this relationship to be super unclear and complicated. For example, MariaDB Foundation is responsible for MariaDB Server, but many other connectors, which you would argue are also necessary parts of the complete solutions, are owned by MariaDB Corporation and released under a variety of licenses. Now, even what you would consider Docker server parts, such as MariaDB Docker builds, are provided by MariaDB Corporation. Now, there are also other bits and pieces which I find interesting. For example, MariaDB knowledge base, which a lot of community contributes to, is hosted and controlled by MariaDB Corporation, even though you would potentially see that as a community project. Now, I also found this interesting experience just a few days ago. If you download something from mariadb.org, you would, after download completes, redirect it to the MariaDB Corporation page, which is, as you can see here, is a form which shows what you are providing the data to MariaDB Corporation, and may choose to share that with MariaDB Foundation as well, while that is not what I would expect as a user, right? If I download something from MariaDB Foundation, I would expect that is where my data would go, and not to MariaDB Corporation, which may use that for a different purposes. The next step, or next question, is what is really open source and what is not in those in MariaDB and MySQL ecosystems. MySQL follows a very clear and simple open core model. So if you think about a MySQL platform, there is a community version of a whole platform, like for example, MySQL in a DB cluster is the high availability solution, which is completely open source, includes open source router, and so on and so forth. And then there is an enterprise version, which is a commercially licensed tools and plugins, which are more powerful, of course, right? For example, you would get MySQL Enterprise Monitor, right, with variety of graphical user interface tools only in enterprise. What also I think MySQL has done very well through history is there have been no components which initially came as an open source and then were relicensed under proprietary license as a community got some traction. In MariaDB space, MariaDB Server is open source and MariaDB connectors are open source, but there are also parts of solutions which are not. For example, if you are building high availability environment with MariaDB, the default and recommended choice is to use max scale as a router, which is not open source, it's business source license. And also the story with max scale is complicated because it was started as an open source project, but then later moved to the proprietary license as it got some adoption, which some people may consider as a form of bait and switch. MariaDB Enterprise Server is also an interesting kind of open source, right? Obviously, MariaDB inherits a lot of a GPL code from MySQL, so we can't really close source the servers. But what they can choose is to distribute the MariaDB Enterprise source and binaries only to customers, and that is what I mean by open source for customers. You can also see Expand Storage Engine, which is something which came through Clustering acquisition, is only available in that proprietary version of Maria Enterprise Server, at least at this point. Now let's look at also about the relationship between the open source and the subscription version. In MySQL, the MySQL Enterprise is superset of MySQL Community. So wherever you use in MySQL Community will work in MySQL Enterprise and some more. There is also aligned release schedule. That means that the MySQL Enterprise of certain minor version and Community, they release at the same day. In MariaDB case, MariaDB Enterprise Server is extended subset of Community. It includes some additional features like Expand Storage Engine, right? But there are also some features which are available in Community version which may not be considered mature enough or not included in the Enterprise or MariaDB Enterprise platform for one reason or another. Right? And also MariaDB platform has its separate life cycle. If you think about the cloud native, right, and I mean by cloud native in this case the Kubernetes focused, here is a situation I think is very interesting for both the database technologies. And I am not using interesting as a complement in this case. If you look at the MySQL, there is an alpha version of open source MySQL Kubernetes operator, which had last commit about 16 months ago, so it's kind of slightly dead. There are a lot of third-party Kubernetes operators and Helm charts, right, other packages available for MySQL from Presslabs, Percona, and a whole bunch of other third parties. With MariaDB, the Kubernetes operator was actually announced as one of the launch operators during the Operator Hub launch by Red Hat. But since that, it was pulled, and if you find that page in archive, a press release or Operator Hub, you will get links not found, or I'm not sure what the exact story behind that. At the same time, there is a commercial MariaDB Enterprise operator available from MariaDB Corporation, right? So this is kind of puzzling to me, because if MariaDB Foundation focuses on the service side and the Kubernetes is really one of the modern ways how you distribute and consume software, I would expect that, as long as the Docker builds, to be on the roadmap for MariaDB Foundation to cover. And of course, for MariaDB, there is a very large amount of third-party Helm or operator projects exist, right? But that is just so foundational piece of infrastructure. If you would use that, you would really want something which is well supported. Database as a service. In this case, we have MariaDB and MySQL conversion community versions are available on a variety of clouds: Google, Amazon, Azure, DigitalOcean, and others. Right? And also MySQL serves as a base for Amazon Aurora, which I would call the most popular cloud fork, right? Which is something cloud vendor forked and didn't release changes. Now, both MariaDB Corporation and Oracle, they offer database as a service for their respectful enterprise versions, right? Which are not available on the other cloud, with exception of, as far as I could find, Alibaba, which also offers enterprise version of MariaDB through partnerships. Both MariaDB and Oracle's MySQL recognize that the analytics is an important part of a modern workloads, and column store engine, which first appeared in MariaDB platform, now is available in MariaDB 10.5, like as a completely open source solutions, while MySQL has MySQL Analytics service, which is available in Oracle Cloud only. As far as I have seen, it's not have been available either in community as or an open source edition so far. So where do we see the focus? If you think about MariaDB, it's initially competed with MySQL on features, getting features out there faster, right, and so on and so forth. But then MySQL was catching up with those, and I see in recent years a lot of shift happened. We focus on comparability and migration features from Oracle, Microsoft, SQL servers. Really a lot of usability for sysadmin DBAs, like for example startup scripts or like shell highlights and so on and so forth are very good in MariaDB. And more recently I see that as a cloud integration and general cloud integration, such as support for S3 storage engine in MariaDB 10.5. MySQL focused more on the traditional MySQL use cases, trying to make MySQL better MySQL. It also worked on improving SQL support, CTEs, windowing functions, like some of the things which appeared in the new releases, as well as trying to tackle the NoSQL market with doc store and very advanced JSON features. Right? We really also focus on usability for developers. For example, MySQL shell, which includes integration with JavaScript or Python. And with a cloud focus, MySQL focuses on the database which can run best in Oracle Cloud rather than general clouds. Also, other clouds, of course, benefit from a lot of features being added to support Oracle Cloud, but that is less priority. And we see MySQL is not focused on advanced Oracle features, right? And there is different theories I have heard about that. Some of them I saw is because the customers, what Oracle has, they're not asking for those advanced Oracle features because they already have Oracle for that. Or maybe that is a product strategy not to disrupt or big Oracle database, right, with MySQL. You can make your own mind here. If you think from an architecture approach, MySQL really started in the recent version painful refactoring on an old code base. We can see in the DB data dictionary problem was tackled in MySQL 8. They introduced Vulkan optimizer. There is a really focus, I think, on prioritizing ease of use and limit choices, saying, hey, you know what, we're not going to really have a lot of storage engines for everything. Let's not have users think about that. We'll just have one default InnoDB storage engine. We'll try to make work for from everything. But at the same time, I think some decisions MySQL took were kind of needlessly complex and sometimes disconnected from reality, right? For example, MySQL GTID's introduction in the time was, well, quite fiasco, right? For MariaDB is more focused on pushing old code base further, right? It didn't have such a massive change as MySQL took in MySQL version, but really it prioritizes a lot of choice and flexibility, support for multiple storage engine, right? And really its development team, I think, is working much closer with the customers and much closer to understanding the practical operations problems sysadmins, right, and otherwise would have. Now, in the recent years, MariaDB also acquired some InnoDB developers, and it has its own philosophy and roadmap on making InnoDB better. And now I think you have a very fun opportunity to compare the Oracle's InnoDB to MySQL's InnoDB to see which one performs well. And I think that is fantastic competition, which we will probably benefit users overall. Here is example of release frequency. If you can see what MariaDB releases much faster than MySQL. If you see in this case, MySQL has a major release every 2-3 years, right? And we don't know when and if next MySQL major release is coming. MariaDB has been working last 4 years almost like a clockwork, releasing the new stable release sometime in May or June every year, right? So very different life cycle. Though that doesn't mean that the MySQL is moving very slow. The release philosophy is also very different. MariaDB continues classic MySQL philosophy, where you have relatively frequent major releases, and then there are no major changes in minor releases. So that's kind of mostly bug fixes and small tinkering, right? And that also means that you can do both upgrades and downgrades, keeping dataset intact. The MySQL 8 is what is called evergreen release, right? They're saying, hey, you know what? We are breaking that old ideas. Now we're going to introduce features in minor releases. And what that also means, you won't be able to do downgrades. Okay, with that, let's look at some more technical specifics. What do we have in terms of client protocol? Both MariaDB and MySQL support classic MySQL protocol, but also MySQL has done some extensions. For example, it supports SRVD next record support, and I think the biggest new thing in MySQL is this thing called X protocol, which allows you to the new protocol, which you can use both SQL as well as a doc store protocol. In MariaDB, it has classic MySQL protocol as well as its own protocol extensions, for example, for progress reporting and some others. If you look at the interface support, MySQL, you can use classical SQL, you can use doc store, you can also use Memcache, talk to that through Memcache protocol. MariaDB supports SQL as well as handler socket plugin. If you look at JSON support, that is, I think, where MySQL is substantially ahead. It has a native JSON data types. It supports very efficient partial updates of large JSON fields. It has things like JSON shortcuts, which you can use conveniently inside of queries. Advanced features such as JSON tables. Where with MariaDB it has some JSON functions, but it also stores JSON as a text field, and there is, I think, a lot of work is being done in MariaDB right now to support JSON better. Replication. In MySQL, you have MySQL group replication and MySQL's GTID. Now it has added also a clone plugin for efficient provisioning, which can be used for both classical MySQL replication as well as a group replication. MariaDB does not support group replication. It uses Galera replication instead, and it uses also its own GTID, right? So replication is something which is a very different between those two databases, and in generally ways how you provide high availability, right? So that is something I would be looking very closely to. In terms of SQL standards and comparability, I cannot find anything big which MySQL has which MariaDB does not offer, right? So I think MariaDB, well, outside of JSON, right, frankly. MariaDB, though, it adds SQL mode equals Oracle, which has a lot of Oracle-like extensions. It supports system version tables, right? Sequence. It supports packages and storage procedures, right? So a lot of stuff to comparability with standard and with other databases. Now, if you want to look into the more detailed feature comparisons, you can check out these fantastic blogs on modernsql.com, though I would point out they are both now about 2 years old. It only covers MariaDB 10.3, and MariaDB 10.4 and 10.5 have more stuff. And also actually MySQL have been adding more features in the new MySQL 8 releases, right? So be careful with that. Security. There are significant difference in security and user account management. You know, how roles are implemented, privileges, the names, what corresponds to, right? All I have, if you're interested to hear some more about the open source databases, including MySQL, MariaDB, I want to invite you to Percona Live Online in October 2020. With that, thank you. Let's keep in touch.
Thank you, Peter Zaitsev, Percona. Great presentation. You're calling in from Durham, North Carolina, the US. Welcome, Peter.
Thank you, Kai.
So you had a couple of observations on the relationship between the MariaDB Corporation and the MariaDB Foundation. I took the liberty of stealing a couple of tricky questions for the Monty Ask Me Anything AMA session right after this. I hope that's fine with you.
Oh, absolutely. Absolutely, Kai.
Great. So I picked another hot topic, the word drop-in replacement. Some people say MariaDB is in practice a drop-in replacement of MySQL, and others enter into religious global transaction ID, GTID wars. So where do you stand on that issue?
Well, I think what MariaDB was a drop-in replacement for MySQL in early days, right? I think it's somewhat drop-in replacement now. But if you look at the path, it becomes more and more of its own database, right? With that comparability reduces, right? I think it's interesting in a world of SQL databases, right? You can argue on some level what all the databases are, or relational databases are interchangeable, right? Because we all speak SQL, but we all know what that is not the case in practice, at least for complicated applications, right? For some, it is the case.
So let's say one is on MySQL, but not yet on 8.0. How do you see the options from that point onwards?
If one is on MySQL and not 8.0.
Yeah, but let's assume that somebody is using MySQL and not yet on MySQL 8.0. So what's the path onwards from there? What are the options?
Well, I think in this case, obviously, one may choose to stay with MySQL or may choose to jump to MariaDB. As I mentioned in my presentation, is what MySQL 8 introduces a lot of revolutionary changes. Right, and MariaDB in certain places is frankly closer to the old MySQL than MySQL 8 is. Right, in terms of what is right for you, what you like, that is really a complicated question, and it's not just a technical question; it's also political question in many cases.
So one of your expressions is evergreen release. If I understand that correctly, it means that in MySQL 8, bug fixes and new features are not really separated, but mixed into the same release. Now, whom does that affect? Is that an issue for application developers? Is it for customers? Or why is it important to know?
Well, I think this is interesting, right? Because if you look at this trend, this is a trend in state of shipping software in many technologies, right? If you look at macOS X, was kind of a major release, essentially with introducing fixes and bug fixes, right, and new releases, right? Or you would look at Windows 10 and so on and so forth, right? Or even in open source like a Kubernetes, right? In every release, which is minor release, there is so many new changes, right? And I think that is the idea. And again, like only on some portion of developers, we can say, hey, you know what? We want access to new features faster. We want faster innovation. And yes, for that, we have to pay with a higher risk, right? And that is the choice MySQL 8 made, right? I don't know wherever that is going to be working out well for them, right? Or more conventional MySQL approach, which MariaDB continues to take, will be better. But that is the difference. Now, a lot of that is also focused in the cloud. I think on the cloud deployments, because in the cloud, you want things to be as much automated as possible. And then if you have to do a big jump with potentially a lot of changes in your application, at certain point, right, it becomes very hard to do that in completely automated way.
So I don't remember if you use the word code drop model, but there's something you use to refer to the development model not being really out in the open with Jira and stuff, where Maria is open, MySQL less so. So whom does that affect? Is it the developers? One would immediately think, well, that's for the developers of the server, but is it also for developers using the server or DBAs? For
yes. I called that helicopter open source, right? When you essentially drop the open source as if they're from helicopter, right? And I think that is the model which Oracle and some others use to protect their interest, right? And like I think for Oracle, most likely it is a lot of that is connected to the AWS, which is like and other cloud vendors, which is the biggest competitor out there. We don't want them to have an easy job, picking up, security patches one by one and so on and so forth. But in the end, I also believe that affects the users of the software in a negative way, especially more active participants, right, in the community, because that means what they cannot see the commits as they happen, right? They cannot comment, oh, you know what, that is stupid. There is a better way to do it, right? You lose a lot of QA, which community can provide to your pre-released versions. You only ship a version, right? And they can only see a released version. If there is any feedback, it has to wait for a number of months to be incorporated in the best results. And in MySQL case, especially the minor releases, right, became slower. We see, 2-3 months between the minor MySQL 8 releases, right? It's not monthly as it used to be years ago.
On that note, I want to say thank you. Very good presentation and very insightful comments. Thank you, Peter Zaitsev.
You're welcome. Thanks.
welcome Monty, Mikael Widenius, for the Ask Me Anything session.
Thank you. I'm looking forward to it.
Well, so am I. So am I. I have a couple of tricky questions for you. Lots of good questions here coming. We're monitoring the Zulip chat for further questions, so we reserve a bit at the end for the new ones, but I've already grouped the questions here into strategic questions and political questions and hardware questions and development questions. And I can tell the viewers, I have not prepared Monty. We'll get the best more answers from Monty by being very spontaneous. So the first question, how do you feel, Monty?
Feeling good. I think the conference is doing great. I was really happy with Peter Zaitsev. He was doing good.
So what do you expect? I won't ask you what do you expect people to ask. Instead, I will pick the first question by somebody whom you know. You've met him in Albania, Tirana, 2005, Erwin Rucci. He's asking, is making MariaDB the fastest database your first priority?
Let's say you can never be fastest in everything, but I do have a sweet spot for performance, and I like to get the most out of the machine. So everything we do, or especially what I do, is regarding to do the best you can with little resources. And I'm happy to see that MySQL 6.0, actually, sorry, not MySQL 6.0, MariaDB 10.6 is about performance. So right. We have the whole team doing mostly performance things that should have been fixed a long time ago, or have kind of just been forgotten. So I expect a lot of new interesting things.
A bit because your questions need to be fairly short because we have so many exciting questions. The second question here is an evergreen that I suppose you've answered many times before. How do you compare MariaDB with Postgres in one sentence?
I think they're both great databases, and it depends on your usage. If you're going to use a cluster setup, then I think that MariaDB is the better choice. We have more experience in that. If you are just using, have an extensible database and you have programmers and you want to do extensions, then Postgres is more suitable for that.
So then a question on the differences between MariaDB and MySQL. So MariaDB is innovating a lot, and sometimes this is from Abbas, is asking that it feels like they are becoming different products altogether when comparing Oracle MySQL, Performance Server, Maria. He believes that features like dynamic columns and JSON type support and InnoDB ExtraDB should be available in all three. What's your take on that?
I think that we are more following the model that we had from MySQL time, where we trying to do stable releases and do maintain most of those, and something that is suitable for community to be part of. MySQL is not doing that. I think from the developed model is totally different. And from there also follows that the feature set that we add will be different.
So a follow-up question from Abbas was, do you think that a free non-BSL version, this is not related to MariaDB Foundation, but it's Ask Me Anything. So anyway, I will ask you, is such a version of MariaDB max scale, will it be made available for binlog use cases?
I mean, what we are doing, have promised, is that all the releases with all features will be available to the community after a certain time. And that's the whole idea with the BSL. So everything that is max scale is now will be sooner or later available to the community.
Then we have another tricky political question. So Heinz is asking, what is the difference between the MariaDB Foundation and the MariaDB Corporation?
So the Foundation is engineered to satisfy users and developers, especially people who want to do commit and help participate in developing MariaDB. And we also take charge of the code in the sense that we guarantee it is always free. The corporation, on the other hand, handles customers and requests where there has to be a timely answer. and help when needed.
So what does that mean from a development perspective?
From a development perspective, the corporation has most of the developers in the MariaDB ecosystem, and they are paying those and driving development. While from the foundation, we have mostly handling pull requests from users, but we're also doing development on things that affects a big part of the user base, and also taking patches from including Percona, MySQL, and the whole community. So we take over the maintenance of those patches when they get into the server.
And what does it mean from a customer perspective?
From a customer perspective, it means that you get the best of the both worlds. You get open source development from a big community, and you have a vendor who can satisfy all your commercial needs and support needs.
So there, the presentation prior to yours was from Peter Zaitsev, and he had an observation that he found it interesting that when you download MariaDB Server from mariadb.org, after the download, you end up with a page from mariadb.com. What's your comment on that?
Yeah, we are trying to be nice within the MariaDB ecosystem, and the corporation provides both support both for the community and customers, and also the knowledge base and everything else. And they provide a lot of extra information that is useful for people who download MariaDB. So we made an agreement that they can maintain that and take that away from the hands from the foundation. I mean, there's no forced registration or anything.
Mm-hmm. Then Vincent is asking, what's being done to address the outstanding multi-year long bug reports, not long bug reports, but year-long bug reports for MariaDB, especially for bugs that cause crashes or data corruption?
Let's say everything that is a crash with data corruption should have a ticket information that says that this is a major and it has to be fixed in the next release. So there shouldn't be any crashing bugs, at least not something that affects a notable part of the user base. There's always corner cases, but not corner cases should also always be fixed in the next release. Mm-hmm. So there's other feature requests that are not critical. They can be in the knowledge base, not knowledge base, but in the Jira quite long until somebody sees a need that get this fixed or added.
Okay, I still have some strategic questions left, but I also have a limited amount of time to ask you. So I'm jumping now to some technical questions. So James is asking, what feature of MariaDB are you the most proud of?
I'm actually most proud of something that's not many people think is interesting. That we actually take good care of our user base. We care about that upgrades are easy. You can take any MariaDB version and upgrade to the latest one or anything in between directly without doing something. And that means that you need to take good handling of both storage, the protocol, and everything else, ensure compatibility. You can also take any old MySQL or MariaDB client and it will work unchanged to MariaDB. This is just so that you have no pain. I hate upgrade with passion because every time I upgrade my laptop, something breaks. And I'm trying to do my best to ensure that doesn't happen with MariaDB. When it comes to features, I think that the replications features we have S3, the online alter table that's a new in MariaDB. They are all exciting, but it's much harder to say which feature is the most exciting one. All developers are looking most closely to what they are coding themselves.
That came from the heart. So now Dion is asking, every piece of software, this is a fun question, so you can relax. Every piece of software can be made to do something it is not designed for. Often when there's something far simpler and more suited to the purpose. So what's the single most ridiculous thing you've seen MariaDB being used for that it really just should not be used for?
I mean, MariaDB is kind of designed for being something that can easily access from the web. But I have horror stories from the old times before MariaDB and my MySQL, where people were just misusing my products. But with the databases, if you try to store the wrong kind of information that is not designed for, then it's a bad thing. But I don't have any real horror stories of that. I'm more about real horror stories of the wrong uses of databases when we go to customers and when they complain about things work perfectly 1 year ago and no things are so slow. And you still today find that they don't have a single index. It's kind of incredible that MariaDB works even in those cases.
So now we're getting more technical. Hamza says that currently JSON as a data type is just an alias for long text when in MySQL, when would the MySQL-like JSON table be planned?
According to the SQL standard, JSON is text, and we are trying to follow the standard. And MySQL did something different for performance reasons, but our JSON is as fast or faster than MySQL, so we kind of proved that that was not needed. And so we are trying to follow the standard, and the only thing that is missing from, or big thing that is missing in MariaDB 10.5 is JSON table. We almost had it ready, but it didn't make the deadline for the release. So that will be in 10.6.
So how do you compare using JSON functions on the JSON data type with dynamic column functions on a blob data type?
Basically, it's more or less the same as long as you have one simple row. Basically, dynamic column is there to say that you can have any amount of columns, not arrays or arrays, but just that. And that's the most common things. The benefit of dynamic columns is that every column is typed. So you know that when you put in a date, you get out the date and you can know it's a date. And that's one of the problems with JSON. You have no difference between dates, string, booleans, or anything else. So if you want to have typed and ensure that you don't get dates that is 32nd of December, you should use dynamic columns.
Mm-hmm. So I have two community questions. So for people who learn and use MariaDB, what guidelines do you have to provide to help learning the source code if you want to become a contributor? How should one behave?
To learn the source code is basically you take a problem and try to solve it, and then you dig into it. And we have tutorials in the knowledge base of how to do that. But when you get a stumbling block, you shouldn't just sit there and trying to solve everything yourself. You should go to the free node or preferably Zulip and connect directly with the developers of MariaDB who can give you hints. And that's the best way to learn. You can also use the email list to ask questions about how does this work and everything else. And especially the foundation, one of the purpose of it is to help newbies. So you can contact the foundation, and if you don't think that we have doing a good job through Zulip or other things, then tell us and we will try to improve.
Mm-hmm.
But doing a pull request is the easiest way to get your code in. But the problem is, as you said, what should you do before you can do that? And then you have to use one of the channels.
Good. Okay, so then I have a fairly open-ended community question. What can I do to help you? So I don't really know whether this is a person who wants to code or write documentation, but if there's a developer who wishes to help with MariaDB Server, what's the type of help that we need?
I mean, you can help either with documentation, or you can spread the news about our fantastic MariaDB Foundation Fest and tell everybody about it. You can add help adding links to MariaDB Foundation and the project. But the best way is just to be active. Go to the email list or Zulip or Freenode and help other users. And you get much credit within the community when you're doing that. We can help both the project and also yourself when you want to get job somewhere in the database environment.
Right. So,
and the last thing is that if you want to do the development in the knowledge base, we have a link for easy to solve issues, especially for newbies. Take one of those.
Mm-hmm. So then I got commercial questions. They are not really related to MariaDB Foundation, but hey, we said ask me anything. So Joel is asking, could you tell us about the high growth of MariaDB in the Latin American market? Have you been to the Latin American market, and what's your take?
Personally, I'm not part of the group who handles customers relationship in that market. But in Latin America, I have been attending MariaDB conferences during this wonderful time when you could still travel. I was been in Peru, Brazil, Argentina, and so on. So I really enjoy being in Latin America, and I would love to start going again when things start to open up. And yeah, but I know when I'm there, there's lots of MariaDB users, but I don't know how many commercial ones.
So the second and last commercial question here is by Santinesh. He's saying, is MariaDB working on some enterprise monitoring tool? And I hope you can say anything about monitoring tools that you know that will be interesting.
Yeah, so we did have some presentation about SkySQL, which is the in the cloud offering of MariaDB, and the cooperation of creating monitoring tools within that environment as a complement to our proxy. So that's kind of coming, and I don't know if the license of that eventually. Currently, you can try them out in the SkySQL cloud. Hopefully, we'll have them under BSL. At least that's my hope.
Okay, then two hardware questions here. Richard is asking, have you started to experiment with ARM server builds yet?
So we have ARM in our build bot. So every single push we do is tested on ARM. So from stability point of view, yes. From performance view, we haven't done any specific optimization for ARM yet. And for that, we need somebody to work with the MariaDB Foundation to make that happen, or the corporation.
So Samuel is asking, what's the plan with NVRAM?
So we already have some patches for NVRAM, in other words, persistent memory. And what we have now is that we can store part of or the whole of the InnoDB redo logs in there, which gives you quite a big boost in performance. And we are planning to do much more. But the question is that when will SSD truly replace hard disk, and when will NVRAM truly replace SSDs? We are trying to work with all vendors to ensure that whatever you are using, you will get the best performance that is possible with the database. As I said earlier, perfect performance is a passion, and I want to use the latest hardware to achieve that.
Mm-hmm. So one more technical question, and then I will go to a fun question. So John is asking about time series databases. Specialized time series database systems are all the rage, he says. How should one use MariaDB to store and query large-scale time series with billions of time series points in a table?
First, let's take it the black and or helicopter view. A time series database is one normal SQL table that has one index less. That's it. So the only thing that you really win with a time series database is that the retrieval on time is faster because everything is sorted according to time. But with modern hardware, how often do you decide which database to use based if you have one index more or less? So I would say that a lot of the hype about time series databases is just that, hype. If you want to run with petabytes of data, we have column store who can handle that. It doesn't need time series because it internally does some of the same optimization that you would do in a time series database. So it automatically notices that in this block, we only have data for this time series. So we only examine that block. So you get the same benefit with column store as you get from a time series database in most of the cases. And column store is totally open source and free, which is not the case for many of the other time series databases.
Mm-hmm. So on that note, I'll still ask a follow-up question because you mentioned column store. So what are the new features that you're most proud of or that you want to highlight in the latest MariaDB version?
Regarding column store?
Well, regarding the latest MariaDB version, it may be column store if you wish to say that, or it may be something else.
In 10.5, we were more concentrating on ensuring stability and fixing things than adding a lot of new features. But the two main features that is totally new is the S3 engine and the column store engine. So those are something that people probably have not tried out, especially not in earlier MariaDB versions, and they definitely should look up on those because they can greatly change how your operations are working.
So then for the fun question, how the sea lion of MariaDB, it doesn't have a name, does it?
No, it's poor, nameless little creature.
And what
do you have a suggestion?
Yeah, I was going to ask, what do you plan to do about that?
In the MySQL time, we had the same problem with a little poor orphan delphin. And we reached out to the community and asked, is there something you can suggest? And I think that we should do the same thing with the poor little sea lion.
Okay, and the suggestion, it should be a suggestion of the name, but should the suggestion contain something else than just the name?
I think that the best part of the MySQL Dolphin contest was that we got lots of really good names and explanation for why this name. And that was really, really funny and helpful. And that actually helped us choose Sakila. So I really would like to suggest that people who want to participate don't only come up with a good name, come also up with a short story, why and how the sea lion got that name.
So we will set up such a competition, such a game for people to suggest a name and the reason for why that is the right name. We will come up also with a deadline. We're talking internally about that at this point in time. But how do you then plan to select the right name for the MariaDB sea lion?
I have a perfect candidate for a judge who knows more about Maria than anybody else, and that's Maria, my daughter.
That's a good suggestion. So let us set up a competition for picking a name for the MariaDB sea lion. It has to have a name, and the name has to have a good reasoning, and it will then be picked out by the person named Maria Videnius, your daughter.
Yep.
So any conclusion?
And I think that, as probably people know, this channel is that Maria and also me are both artists. They do great things, and I think that the one who suggests the best name should get a picture from both of them.
That sounds like a great suggestion that I think we can implement. So any concluding words? Was there a question that you had expected to get that you did not get?
Not really. I'm here with a totally free mind.
So any concluding words, any wishes for the users that you wish to tell them?
Yes, please tell them that we are still continuing this fest the whole week. If you have people in China or Asia, please tell them that this is excellent time to join and get more information. And please spread the news about MariaDB to everybody you know. So, and about the foundation to all your developers, so we can continue the work that we are doing.
Right. So tomorrow, still later on today, we will continue in New York. Tomorrow is the third and last day of New York. Today is the last day of Paris. And as you say, on Friday, Saturday, Sunday, we'll do Singapore and Beijing. So that's the end of the first MariaDB Server Fest that we're having this week. So with those words, thank you, Monty. Thank you, Mikael Widenius, for the Ask Me Anything session.
Thank you.
The next presentation, Sasha Vanyachin, Building a Relational Data Lake with MariaDB Column Store.
Hello. I am presenting on behalf of Virtual Health, a growing startup that provides software as a service to healthcare insurance companies. But the problem we are presenting is not specific to healthcare. In many applications, transactional data became less relevant to daily operations with age. In contrast, as historical volumes grow, the data became more valuable for analytics. Here, we describe the relational data lake approach for storing daily, read-only snapshots of transactional databases. To lower the costs, we chose MariaDB Column Store because of its inherent data compression and Amazon Web Services S3 storage support. 10 years ago, James Dixon, founder and former CTO of Pentaho, came up with the data lake concept. A crucial data lake aspect is retaining the source data in its original form and format. I will elaborate more on the importance of this particular aspect later in the slides. Another problem we're addressing here is not unique to virtual health. Operational systems in healthcare are complex and not directly suitable for analytics or machine learning algorithms. We chose to build the data pipeline to MariaDB Column Store since it already provides open source examples of integration with Jupyter Notebooks and Apache Zeppelin, popular open source tools used for data exploration and analytics. We present our data pipeline and share tips and tricks we have learned in the process. To conclude the introduction, I remind of a known problem of running analytical queries on the transactional database that can be slow and painful. To address this problem, a special storage format, columnar, can significantly improve performance of analytical queries. In this talk, we will focus on the MariaDB Column Store. We will show some representative use cases and demonstrate how MariaDB Column Store can be used for typical analytical queries. Why some queries are slow in transactional databases? Let us find top 10 clients who visited doctors most often. Such ranking queries are known to be hard for relational database technologies. Thus, it is not surprising that this query is so slow. As a side note, please take a look at the locations column highlighted on this slide. Why we are so interested in visit locations? This is just one example how our software reduces healthcare costs by enabling booking multiple doctor's appointments in one location. Coming back to the query speedup. What about indexing? this query is already using index, as shown on the query explained plan. What about additional index? Indeed, adding covered index does help. But the query is still slow, particularly for user interface, when users tend to reload the web page when the query is so slow, which in turn overloads the database with repeated slow queries. But the first ranking query example was only the beginning. How about the second ranking query? Identifying high-value clients. Please note that multiple table joins are not uncommon when the schema is highly normalized for transactional performance. You must be truly patient to get the result. It took over 9 hours to learn that some clients experienced the most expensive treatment. As a homework, you may do your own web search to learn more about it. Let me summarize why our analytical queries were slow in the transactional environment. This is because most relational databases, such as MariaDB, are row-oriented. If query needs 2 columns, it will read the whole row. InnoDB organizes tables by pages, resulting in even more data to be read in. And the last but not least, MariaDB will use only 1 CPU core per query. In case of our first ranking query, the row-oriented database have to read the whole row to get the data for just 3 columns, as shown on this slide. In contrast, the column-oriented databases read only the data from the 3 columns involved in the query. Now let me present the results of our comparison of the InnoDB versus column store. The comparison was done using 2 different EC2 instances, small and very large. And let me describe here our first tip regarding the column store that happens to have 2 installation options. The single node, not distributed option is useful for initial evaluation, but it is not expandable, which is often overlooked. This explains why we started with the distributed installation on the single node, which may look confusing, but is unavoidable if you plan to add more nodes in the future. What about the first ranking query? There is no large difference, since the added covered index is essentially an equivalent of the column store, reading data from just 3 columns. However, our conclusion is that the column store is preferable, since you cannot add covered indices for all of your analytical queries. What about the very large query? Let us find out. Well, this query is indeed challenging. The extra tuning is necessary. The solution is to allow the disk-based joins. After the column store restart, we are ready to try again, and wow! Even with disk-based joins, the column store performance is more than 2 orders of magnitude faster. The performance can be improved further when the joins fit in memory. Another column store benefit is a reduced storage. In our case, we observed an overall factor of 4. Half of that is due to a compression, we have a lot of binary encrypted protected health information data that are not expected to compress well. And another half is from indices removal. For the lack of time, I refer to other column store presentations to learn about this feature in more details. With such an impressive performance gain, we clearly need to transfer data to the column store. But how? What about the traditional extract, transform, and load approach? Since MariaDB column store has a built-in transactional engine, we use an asynchronous replication slave as our data staging area. As I said before, the crucial data lake aspect is to minimize data transformation to retain its original format. For data load, we take advantage of two built-in MariaDB and column store engines and use a simple but elegant approach. Stop replication, load data using in parallel the internal, very efficient binary data transfer, then resume the replication. In our approach, we essentially implemented the so-called ELT, not the traditional ETL. This is in line with the general shift towards ELT. The shift is enabled by an increased computing power and capabilities provided by the cloud. In practice, one must transfer the database schema as a first step. In a first approximation, it is rather simple. You just replace engine in a DB with column store. However, this doesn't work out of the box. These slides list certain steps you need to take to eliminate DDL differences, such as the absence of explicit indices in the column store. Also, some data types are not supported. We used the replacements listed on this slide. Here are some other differences that we encountered. Some of these are legacy and not needed in the original schema. Also, virtual columns are not supported. We expect that since virtual columns has no additional data, they can simply be omitted. But those differences were rather trivial. Here we need to dive deeper as it relates to subtle differences in the known issue with null values versus empty strings for certain string data types. As documented, implicit value for string types is an empty string. Here we are converting the schema to column store as is. But then, as documented, the column store treats a zero-length string as a null value. As a result of these features, during data transfer, you will get an error, as shown on this slide. To resolve this issue, more schema tweaking is needed. You may need to remove not null for columns for all strings data types. As you may expect, the list of reserved words is different, which creates some extra issues. For those schemas that have the table user, like in MySQL user. A recent example of such schema was presented at the MariaDB webinar. As we iterated over the schema conversion, we found that Docker images are very helpful in this process. Now, to the most advanced part of the presentation, data import. Here are more technical details about the approach. As documented, it is using very efficient binary data transfers behind the scenes. In certain cases, you may need to execute such command lines yourself, as we described in the next slides. This is because the internal approach may not work for you, as it provides no interface to control the separator, such as in cases of data having the / character. To debug such failures, please take a look at the error files generated in your data directory. For those cases, we used the command line as described on the slide. Also, we had to switch to the command line to increase the read buffer, as shown on this slide. Here is another case to use the command line to preserve the original data values, since by default the column store will replace null values with zeros for the nullable integer or date and time columns. Also, for the very large tables, you may encounter the error shown on the slide. In that case, you just need to tune configuration further as described. Fortunately, this could be done online. And the last but not least advice is to disable the binary login during data transfer. Otherwise, you would accumulate huge binary log volumes during data import. To conclude, let me clarify first that on the numerous issues we described in our previous slides, please do not get the wrong impression that column store is some kind of an emerging product with associated issues. On the contrary, the successful load of healthcare data to the column store is attesting to its level of maturity. The healthcare records are notoriously complex. You may get a preview of this complexity by looking at a couple of open source electronic health record projects that have about 200 tables each. The virtual health database schema is on par with more comprehensive commercial electronic health record systems that have 3 times as much more tables and thousands of columns. Summarizing, let me conclude that the relational data lake built with MariaDB column store retains the source data in their original format. We observed analytical query speedup of more than 2 orders of magnitude, and the native MariaDB protocol lowers application integration barriers. Thus, we look forward to evaluate the latest MariaDB community server version that includes the column store plugin with S3 storage support. Also, the data lake approach looks attractive for data archival. Here, data lake retention of the original schema simplifies application data access. Thank you for your attention. Any questions?
Thank you, Sasha Vanyachin. Great column store presentation. You're calling in from Raleigh, North Carolina, the US, right?
Yes, I am.
Welcome here. So I have an easy first question for you, and that is, why did you pick MariaDB column store? Did you consider other columnar databases?
Yes, we evaluated another open source database, ClickHouse, earlier. And for some benchmarks, it was faster and provides better compression. However, we have concerns regarding MySQL client compatibility That is why we chose MariaDB column store for better integration with MariaDB Server, as we shown in this presentation.
Right. So then when looking at the presentation and following column store in general, I'm a bit confused by the version numbering. Starting from a MariaDB perspective, I know 10.0, 10.1, and can calculate up until 10.5 or 10.6. But you talk about 1.2.5 and 1.5. So can you say something about the version numbering and what's the difference between the column store version number and where does it fit into the greater MariaDB server version numbering?
Yes, so the edition we used is a community edition that is general availability, which is the 1.2.5 column store, which corresponds to MariaDB 10.3.16, which is far behind the latest and greatest 10.5 release. And we are in the process of preparing for the upgrade because it includes the very much refactored column store engine 1.5. See the big jump in version numbers, but just an alert for everybody out there. It includes not only the beta version, but a little bit higher learning barrier because the control commands are totally reworked and requires more time to prepare for an upgrade.
Mm-hmm. So where are you now in test? You spoke about the latest and greatest. So how far are you in your own testing of the latest and greatest?
So we are plan to complete it in about 1 month.
Cool. So replication, I'm trying to understand there if you are part of the application in InnoDB and part of it in column store. So is it a good idea to use slave replication? It seems that you're not using that to get data into column store. So what's the idea here? What are you using and what should one use?
So again, we're taking advantage of the traditional asynchronous slave replication to populate MariaDB server, which is a built-in part of the column store. So we're replicating data to InnoDB, and we have a live replica of the our transactional database in this column store instance. Mm-hmm. But the whole idea of the data warehousing and the data lakes is to preserve a fixed snapshot of the data taken at a certain time. So our goal here is to preserve daily snapshot of the transactional database. So that is why we are kind of using, again, what we call the simple but elegant approach that we stop replication. We got, at this moment, a frozen snapshot of our data, and then we are using those native, highly efficient binary data transfer commands that transfer data from InnoDB to the column store engines. And as we understand right now that MariaDB slave replication to column store does not batch the update. So it should work well only for those tables that are slowly changing, like configurations table, dictionaries and such, but not for the transactional tables where multitude of daily activities happen.
So what about the rest of MariaDB around it? How well does it work with the column store, such as the MariaDB audit plugin? Does it work with the column store?
Yes, we tested. It works out of the box as documented, and we must use it when the column store will be deployed in a different capacity as we plan the so-called data archival. Because right now in the data lake, we keep the de-identified data. We do not have there the protected health information. So we are not regulated about auditing, but as soon as we start using the actual patient's data, we need an audit plugin, and it works fine.
Good. So any concluding words, any observations of questions that you got on Zulip? Anything else you wish to tell the audience at the MariaDB Server Fest?
I see only a message. I think one good thing is that the row store and column store are compatibly provided by one company, MariaDB. And I fully support and repeat this message. It is a great product which has integrated the so-called hybrid transactional and analytical capabilities in one package. That's a great call from MariaDB, and we look forward to use this.
Great. Those are good concluding words. Thank you, Sasha Vanyachem. The MariaDB Server Fest Paris 2020 is now over, and what a fest, what a feast it was. We're happy to have been able to interact with our user base. As I said when we started, we're usually talking to the developers of MariaDB Server itself. Now we've been talking to database administrators, DevOps, and developers of applications using MariaDB Server. And that feels good. That's what the MariaDB Foundation is there for. We work on openness, meaning contributions of code to the MariaDB Server codebase, but also on adoption, helping DBAs and developers to use MariaDB Server more and better. And that's what we've been doing here in Paris, and it feels good. So some numbers on the live stream on YouTube. So Paris Day 1 had over 2,000 views and over 400 thumbs up. So far, no thumbs down. Paris Day 2 had close to 500 views and 500 thumbs up, and we expect the views still to grow. That's how YouTube statistics seem to work. We're still learning. And on top of that, we have 400 views and 500 odd thumbs up from New York day 1. So it seems that the running of the conference several times in different time zones is also working. So looking back at some innovations for the format of this conference that we stated to begin with, and a bit looking at the experience of how it then worked out. So the basic thing here was that we required pre-recorded presentations, and I think that worked out well. It provided us with resilience, or the audience with resilience, and us with peace of mind. So we got some graceful degradation with the hiccup in the situation where we had Valery Kravchuk connectivity being lost. So we had backup there with people who could fill in. He could give the normal presentation, and the Q&A was then filled in by others. There were some heart attack inducing moments, but that would have been way much worse if we didn't have pre-recorded presentations. So then subtitles. So one observation that we had in this conference was that quality does not correlate too much with the ease of understanding accents, meaning the relevance, the significance, the insightfulness of a presentation can come from people who are not trivial to understand from a pure accent perspective. And I think that subtitles can help a lot here, and I hope you had the benefit of reading the subtitles and hence understanding some of the presentations much better. Then pre-recording also means availability later on. You might say that we are making a virtue out of necessity here. You might be right, but we see this as a clear advantage. And this advantage we're taking by making the URLs or keeping the URLs constant all across from when the abstract was first published to now the recording being soon available there on each of the pages for each of the talks. And then another and the final key innovation here was the chat, the Zulip chat. The purpose here was, since we were already in possession of the recording of the presentation, we've sort of cloned the presenter. The presenter can be there and now give complete attention to you, the audience. And I think that worked out. We got hundreds and hundreds of chat interactions over Zulip. That worked out as we hoped. So we also had different topics for different talks, and that kept things clean. So when one presentation ended, then the audience of that presentation could come up to the podium of that speaker and continue chatting without disturbing the next presentation, which was starting, so to speak, in another room, on another topic within the same stream on Zulip. And these chats are still available on the net, and they will be linked from the individual presentation URLs that, as I said, will be kept constant. So what happens from now on after the conference? Well, first of all, the recordings on YouTube. So the videos stay there. The live stream, which is what we've so far been broadcasting, it will be chopped up into individual talks. And each of the talks will get their Q&A, question and answer, video recordings separately uploaded on those pages. And speaking of YouTube, please subscribe to the MariaDB Foundation YouTube channel. We have other videos there as well, short ones, tutorials created, especially not just recorded talks, but tutorials especially created for you to view on YouTube in addition to these recorded talks. And a request from our side to you is to share your thoughts over social media. Share those links, those URLs to the talks. We've done our best and we will continue to do our best to make those web pages with the talks as useful as possible. We're still updating them, as I said, with the chat references now also after the conference. They will stay there and they will include the recording, the subtitles, the Q&A sessions, the online chat. So please share these URLs with the people you think may have use of it, over email, over LinkedIn, Twitter, Facebook, WhatsApp, whatever medium works best for you. Another request for you is to stay in touch over Zulip. Now you know we're available over Zulip. We'll keep those topics open. It's not a place for free support, it's a place for giving feedback to us. And use our normal channels. And one channel I really want to underline here is Jira. Use Jira to report bugs, use Jira to suggest enhancement requests and to vote on them. That's how we work, and it's at jira.mariadb.org. It should be easy to remember. Now I want to thank people, and first and foremost, the presenters. I want to thank you all, the presenters, for pre-recording the presentations and for being here in Paris over Zoom and for being also in New York over Zoom and soon in Singapore and Beijing. You certainly put in a lot of effort for this. I also want to thank you, the audience, for the interactions over Zulip, for listening, for your time and for your attention. Then I want to thank the MariaDB Foundation team behind this. And first and foremost, the video editing team in St. Petersburg. People believe it's a large team, but it's a one-man team, Alexander Morozov, who does wonders and magic. I also want to thank the overall coordinator and cat herder of the MariaDB Server Fest 2020, Anna Videnius, in Grankulla, Finland. I want to thank the schedule and subtitle master, Ian Gilfillan, in Cape Town, South Africa. I want to thank the web coordinator and general fire soldier fighting whatever fires occur, Vicențiu Ciorbaru, now with us here in Grankulla, but usually in Bucharest, Romania, with his webmaster, Andreea Hendea, back in Romania. And then I want to thank the rest of the MariaDB Foundation team, Daniel Black in Canberra, Australia, Faustin Lamler in Venice, Italy, Anel Husakovic close to Sarajevo in Bosnia, Vlad Bogolin in Bucharest, and Robert Bindar in the southern Romanian countryside. And speaking of these employees of the MariaDB Foundation, I want to extend a special thank you note to our platinum, gold, and silver sponsors. You pay our salaries. We're very grateful. Our platinum sponsors are MariaDB Corporation, Booking.com, Microsoft, Alibaba, Tencent, and ServiceNow. Our gold sponsors are Visma, IBM, and DBS Bank. Our silver sponsor, Automatic. So in conclusion, we are happy, and we hope you are happy too. We got lots of interactions with you, but we want more. We established a special topic for this feedback on Zulip. There's a topic here called Conference Feedback to MariaDB Foundation. Keep your feedback coming on this topic. We're going to ask you, and we hereby ask you, how can we increase your benefit from this conference? How can we help you use MariaDB more and better? What are your suggestions for our next MariaDB Server Fest? Timing, format, content. I'm Kai Arne, CEO of the MariaDB Foundation, traveling home now from virtual Paris. Thank you and see you next time.